is modern physics ma. So in modern physics, these are the topics which we'll study ma. Atoms, nucleus, dual nature of matter and dual nature of radiation, and electronic devices. Okay ma. So first of all, we will study of atoms, or you can call it as atomic structure also. So in chemistry we study atomic structure nama. Similar discussion now we will do in physics also. See my first model of atom. Okay ma. So many people try to understand what atom is made up of. Are you able to understand? So the first person who has done this type of trial is Thomson. Okay. So he said that atoms are just like a positive mass in which negatively charged electrons are present, just like seeds in a watermelon. So this was the statement which was given by Thomson. So he said that atom is just like a watermelon ma. So total mass is present inside this atom, and what is the charge of the mass? Charge of the mass is positive. Are you able to understand ma? So inside this positive mass there are some negatively charged particles, and these negatively charged particles he called them as electron. Are you able to understand? And total mass which is present inside this atom, that he called it is made up of positive charge, and electrons are just like present, they are seeds in a watermelon. Okay ma? So this was the first assumption which was given by Thomson. Okay, but this model is not correct, this model is wrong model. Okay, so next trial was done by Rutherford, and before studying Rutherford we have to study the experiment of Rutherford's. Okay ma? So Rutherford's gold foil experiment. Okay ma? So Rutherford's gold foil experiment, if we study, then some conclusions we will get about this gold foil experiment. Are you able to understand ma? So what he has done, he has taken a very thin sheet of gold. Okay ma? Very thin sheet of gold, and surrounding this gold foil he made some sensors on which zinc sulfide, it is painted on the inner surface. It is a luminant material. If somebody goes and strikes this zinc surface, it will glow, or some markings will be formed on that zinc sulfide screen. Are you able to understand? So this is a gold foil, and from here he bombarded some alpha particles. All these experiments you know no ma? So he bombarded some alpha particles. What is meant by alpha particle? Alpha particle is nothing but helium nucleus. Nucleus of helium is there no? Helium atomic number 2 no ma? So if you remove 2 electrons from helium, then only nucleus will be present. Okay, subaka vinali ఏదో చేస్తూ ఉంటే ఏం అర్థమవుతుంది? ఇట్లా 10 సంవత్సరాలు ఎన్నో అర్థం కాదు మీకు, చెప్పేది చాలా కేర్ఫుల్గా వినండి. క్లియర్ మా? సో వాట్ ఈస్ meant by alpha particles ma? Helium nucleus is called as an alpha particle. Are you able to understand? Helium atomic number 2, it means there are 2 protons and there are 2 neutrons and there are 2 electrons also. So if you remove both the electrons, then only nucleus will be present in helium number. That nucleus is nothing but alpha particle. So therefore what will be the mass of this alpha particle ma? Mass of the alpha particle will be how much? Atomic number enta 2. 2 means what? 2 protons will be there, 2 neutrons also will be there. So its mass number is how much? 4. And what is its atomic number? Atomic number is 2. So this is called as an alpha particle. Are you able to understand ma? So he made some millions and millions of alpha particles to go and strike this what you call a gold foil. Are you able to? Very thin sheet of gold foil, so thin that it is almost transparent. Very thin sheet of gold foil. Are you able to understand ma? Then he observed that most of the alpha particles, they were passing through the screen. They were not deflecting. Most of the alpha particles. Are you able to understand ma? So that was the observation which was done by him. So what is the first point, note point we have to write now? First of all we will write what is an alpha particle. Already we have written now ma? So from helium atom, if two electrons are removed, then it is called what? Then it is an alpha particle. Are you able to understand? So he bombarded many alpha particles. So millions and millions of alpha particles he made to fall on this gold foil. Clear? Then he observed that what he has observed. Actually, this experiment was started by Rutherford along with his students. He had two brilliant students, names were Gregor and Marsden. Okay, so he tried to find out what atom is made up of. Are you able to understand? So he tried to bombard these alpha particles B, but he observed that many of the alpha particles, Sarshia, Koski's Lokam Mehetumana, Sumna. Clear ma? He observed that many of the alpha particles, they were not different. So he has done, along with his students, many times he has done this experiment and he could not get any result. చాలా సార్లు చేసినాడు ఆయన కూడా చేసి ఏం విషయం తేలలేదన్నమాట, ఇది అయ్యేది కదలేని వదిలేసినాడు. But his students, he continued performing the same experiment hundreds of times. Able to understand? మా మాస్టర్ ఏదో చెప్పినారంటే ఏదో విషయం ఉంటుంది నమ్మకం అన్నమాట వాళ్ళకి. So they performed the experiments hundreds and hundreds of times, same experiment. Then at one instant of time, they observed that one alpha particle exactly retraced the path. ఒక alpha particle ఏం చేసింది? One alpha particle, it went like this. Are you able to understand ma? And it exactly retraced the path. అది అబ్జర్వ్ చేస్తున్నారు వాళ్ళు. క్లియర్ మా? Then immediately they went and informed to their teacher that we have observed that one alpha particle has returned back. Are you able to understand ma? So therefore what happens here? So most of the alpha particles traveled undeviated. Okay ma? Very few particles deviated. Are you able to understand ma? And one out of every 20,000 particles returned back at an angle of 180 degrees. Are you able to understand ma? So out of how many particles ma? Out of 20,000 particles, only one particle was returning back. Okay ma? Then Rutherford came to a conclusion that alpha particle is quite heavy particle no ma? It is not a very small particle. Alpha particle is a heavy particle. Its mass number is 4. Are you able to understand ma? So if such a heavy particle, if it is able to return back, even though its velocity is very large, then he assumed that this alpha particle should have collided with a very large mass. Okay? అంత పెద్ద ఆల్ఫా పార్టికల్ ఎగ్జాక్ట్లీ 180 డిగ్రీస్లో అదే వెలాసిటీతో రిటర్న్ అయింది అంటే మీనింగ్ ఏమి? అది దేంతో ఒక పెద్ద మాస్తో కొలైడ్ అయి ఉండాలి. ఓకేమా? అండ్ హీ నేమ్డ్ దట్ హెవీ మాస్ టు బి న్యూక్లియస్. ఆ హెవీ మాస్ని ఏమన్నాడు అతను? న్యూక్లియస్ అన్నాడు. అండ్ మెనీ పార్టికల్స్ దే వర్ ట్రావెలింగ్ అన్డివియేటెడ్. సో దేర్ ఫోర్ హీ కంక్లూడెడ్ దట్ మోస్ట్ ఆఫ్ ద ఆటమ్ ఈజ్ ఎంప్టీ. ఆటంలో చాలా వరకు ఎంప్టీ స్పేస్ ఉంటుంది. And nucleus is a very heavy particle which is present somewhere in the nucleus, and the area or volume occupied by the nucleus is very small. So these were the conclusions drawn by this gold foil experiment. So therefore what are the conclusions he has written? Clear nama? Conclusions are, okay, most of the atom is empty. Okay, and what is the size of atom he has calculated? Size of atom is 10 power minus 10 meters. Are you able to understand? Second observation is, there is a very heavy particle called nucleus at the center of atom. Okay ma? and its size he calculated to be 10 power minus 15 meters. Are you able to understand? So what is the size of atom? It is 10 power minus 10 meters. Are you able to understand? And what is the size of nucleus? 10 power minus 15 meters. So which one is bigger, which one is smaller? Which one is bigger? Size of atom is bigger. 10 power minus 10 is a very big value when compared to 10 power minus 15. How many times bigger? 1 lakh times bigger. Are you able to understand, ma? Therefore, size of atom is nearly 1 lakh times bigger than size of nucleus. So this was the conclusion which he has drawn. So understood how gold foil experiment has helped to find out what is atom composed of? Are you able to understand now? So out of every 20,000 particles, only one particle was exactly retracing the path. Ye path lo vellinదో ade path lo veniki vachindi. It means that there should be a very heavy particle. But many particles, they were not deviating. It means most of the atom is empty. Only at the center of atom we have a very heavy particle. Are you able to understand? Then how this next, what about this alpha particle? Is it a positively charged body or a negatively charged body? Okay, ma? Alpha particle 2,4, is it a positively charged body or a negatively charged body? Nucleus. It is a positively charged body. Why? Helium particle means only nucleus, no? Electrons are not there, only nucleus. Okay? Nucleus of helium atom is called as alpha particle. So nucleus is positively charged or negatively charged? Positively charged. And nucleus is returning back, no? Alpha particle is returning back. It means somebody is reflecting that alpha particle, no? So therefore the nucleus of gold foil also should be positive. Are you able to understand? So therefore he concluded that nucleus of gold foil is having which charge, ma? Positive charge. Because only positive charge can repel a positive charge. Are you able to understand? So this is another conclusion he has drawn. Another conclusion is that, so if what you call nucleus is very small, then how this atom is able to maintain its size? Nucleus chala chinnadi, atom is very big. How atom is able to maintain its shape? Total mass is only because of nucleus, no? For the atom, total mass deni vallu untundi? Total mass only because of nucleus only, because protons and neutrons, they are present inside the nucleus and they are very heavy when compared to electrons. But how this atom is able to maintain its shape? Ela maintain avutundi cheppandi? See, when you take this building to be a nucleus, then this total Kadapa district, you can call it as atom. Atom size antunte, nucleus size antuntundi. Are you able to understand? But total mass is present inside the nucleus only. Then how this nucleus or how this atom, it is able to maintain its shape and size? How? Because it is possible only when electrons, if they are rotating around the nucleus. And these electrons, they should be negatively charged. Are you able to understand, ma? So therefore he said that, for example, if it is a nucleus which is a positively charged body, so if electrons, if they are rotating around this nucleus, okay, ma? Only because of this rotation of electrons only, this atom is able to maintain its shape. Are you able to understand? So consider here there is an electron. An electron is what kind of body, ma? Negatively charged body. And nucleus is what kind of body? Positively charged body. So this nucleus will be continuously attracting this electron. Nucleus will be continuously attracting the electron. But why electron is not coming to the center? Electron is dani paina padipodu kada. Why? No. Because this electron is in rotational motion. Somebody has set this electron in rotational motion. So centripetal force is provided by this force of attraction. Are you able to understand? It means somebody should have given this electron some tangential speed. ఎవరో ఈ ఎలక్ట్రాన్కి టాంజెన్షియల్ స్పీడ్ ఇచ్చి న్యూక్లియస్ పక్కలో పెట్టుండాలి. Are you able to understand? This electron is always trying to move in a straight line. ఈ ఎలక్ట్రాన్ ఏం చేసే ప్రయత్నం చేస్తుంది? This is always trying to move in a straight line. But because of this force of attraction, it is continuously changing its direction. So this force of attraction, this is providing the centripetal force. Are you able to understand? So because they are rotating in circular orbits, that is why atom is able to maintain its size and shape. Are you able to understand? Now the question is, who set this electron in tangential motion? Adi evaru? ఇంత చాలా ఎక్కువ వెలాసిటీ ఉంటుంది. వెలాసిటీ ఆఫ్ ఎలక్ట్రాన్ విల్ బి వెరీ 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 లార్జ్. అంత వెలాసిటీని ఇచ్చి కరెక్ట్గా న్యూక్లియస్ని ఇట్లా పట్టుకొని దాని పక్కన ఈ ఎలక్ట్రాన్ను పంపించాలన్నమాట. అప్పుడే అది సర్క్యులర్ మోషన్లో తిరుగుతూ తన షేప్ని మెయింటైన్ చేస్తుంది. నువ్వే కనుక్కోవాలి. ఆర్ ఏబుల్ టు అండర్స్టాండ్ మా? సో దిస్ ఈస్ వాట్ ఈస్ హ్యాపెనింగ్. సో ఎలక్ట్రాన్ ఈస్ ఏబుల్ టు మూవ్ ఇన్ ఎ సర్క్యులర్ పాత్ because somebody should have given tangential speed. And what centripetal force will do? Centripetal force will continuously change the direction of a body. In circular motion we have studied no ma. Straight ga veltunna body ki evaranna perpendicular force iste tana direction ni marchukuntundi. Okay, so electron is always trying to move in a straight line, but centripetal force is making the electron to continuously move in a circular path. This is the assumption which was done by Rutherford. Are you able to understand? So therefore, what is the next conclusion he has given? Atom is able to maintain the shape and size because of what? Because of electrons rotating around the nucleus. Rotating around the nucleus. Are you able to understand? Because electrons are rotating, that is why the atom is able to maintain its shape. If they doesn't rotate, what will happen? If rotate avvakapothe em avutundi? All these electrons, they come and fall on this nucleus. Electrons anni poyi nucleus paina settle ayipothayi. Endukala? Because there is force of attraction. There is force of attraction between positive and negative. Because of that, they go and settle on the topmost portion of the nucleus. Are you able to understand? Then what happens? ఈ బిల్డింగ్లో అంతా ఎలక్ట్రాన్స్ న్యూట్రాన్స్ ఉన్నాయి కదా, ఇవన్నీ ఇంత సైజు ఉన్నాయి ఒక్కొక్క ఆటం. సో ఎలక్ట్రాన్స్ అన్నీ పోయి న్యూక్లియస్ పైన కూర్చుంది అనుకోండి, ఈ బిల్డింగ్ అంతా అంత బాల్ అవుతుంది అంతే. ఆర్ ఏబుల్ టు అండర్స్టాండ్? ఈ బిల్డింగ్ సైజు 1,00,000 టైమ్స్కి తగ్గిపోతుంది, అంటే అంత బాల్ అవుతుంది అంతే. ఓకే, సో నేచర్ ఈస్ ఏబుల్ టు మెయింటైన్ ఇట్స్ షేప్ అండ్ సైజ్ ఓన్లీ బికాస్ ఆఫ్ ఎలక్ట్రాన్స్ దే ఆర్ రొటేటింగ్ అరౌండ్ ద nucleus. Are you able to understand? That is the second observation which was given by Rutherford. Are you able to understand? So therefore he said that these electrons, they are rotating around this nucleus just like planets are rotating around the sun. So this is not correct actually, 100% it's not correct, but some of the part it is correct. Are you able to understand? So he said that electrons are rotating around the nucleus just like electrons are revolving around the planets are revolving around the sun. That is why this is also called as planetary model. ఈ మోడల్ ఏమంటాం మనము? దిస్ మోడల్ ఈస్ కాల్డ్ యాజ్ planetary model. Okay, so by using gold foil he could conclude these many conclusions. Is it clear, ma? That's it. But the problem is here there is a drawback. So scientists accepted his model, but they put a question to him, and that question could not be answered by Rutherford. So what is the drawback of this model? Main drawback. There are many drawbacks. Main drawback I am writing. Main drawback is that if electron continuously revolves, okay ma, why it is not losing energy? This was the question which was put forward by other scientists. See, if any body, if it is moving, it should lose energy, no? Okay, ma? Why it is not losing energy and why it is not falling on the nucleus? So actually according to classical mechanics, clear nama? For example, if this is the electron, continuously it should lose energy and finally it should fall onto the nucleus. Okay, this is what should happen. But this is not happening. Electrons, they are continuously rotating around the nucleus from millions and millions of years onwards. Okay, why it is not losing energy, that he could not answer. Are you able to understand? So this is about the model which is called as Rutherford's planetary model by using gold foil experiment. Okay, ma? Make a note up to here. Rutherford has done some calculations, ma. Those calculations we will study here. So listen very carefully. See, ma, first calculation is distance of closest approach. What is meant by distance of closest approach we will see, because many times questions were given on this topic. Okay, see, ma. So this is the alpha particle which is present at a large distance initially. Initially it is present at a very large distance. Are you able to understand, ma? And what is the charge of alpha particle? It has only 2 protons, no? So its charge will be 2e. E means charge of an electron. Charge of an electron, charge of proton, both are same, no, ma? 1.6 into 10 power minus 19 coulombs. Okay. So charge of alpha particle is 2 into e. And this is the gold nucleus, gold foil nucleus. And its charge will be 79, no atomic number, so 79 into e. So instead of gold, if you place any kind of atom, so you can write Z into E, where Z is the atomic number of that atom. Are you able to understand, ma? So Z into E is the charge of gold nucleus, 2E is the charge of alpha particle. Now see, ma, when this alpha particle starts coming towards the nucleus, so the kinetic energy of alpha particle decreases and potential energy of the system increases. How can you say? Are you able to understand? So when it starts coming towards the nucleus, kinetic energy of the system reduces, potential energy of the system increases, because when it is at a large distance there is no force of attraction or force of repulsion, no? But when alpha particle starts coming towards the nucleus, then there is a force of repulsion between them. Rendu tension lo untai. And energy possessed because of size, configuration, position, that is called potential energy. Okay, ma? So kinetic energy slowly reduces, potential energy continuously increases, but total energy is always a constant. Okay, and what kind of forces are present here? Electrostatic forces. These are electrostatic charges, no? And forces are electrostatic forces. Electrostatic forces, they are conservative or non-conservative? Conservative force, gravitational force, electrostatic force, spring force, nuclear force, all they are conservative forces. It means in this system only conservative forces are acting, no? Okay, ma? So what is happening here? Only electrostatic forces are acting. Okay, ma? See, ma, he did not do this total calculation. I am doing this calculation, but finally we will go to the same answer. Okay, only electrostatic forces are acting, and electrostatic forces are what kind of forces? Conservative forces. Okay, if only conservative forces are acting, I can use law of conservation of mechanical energy, no? Okay, so K1 plus U1 is equals to K2 plus U2. This we can do, no? Are you able to understand? If only conservative forces are acting, definitely I can use law of conservation of mechanical energy. Initial kinetic energy. So let us consider this alpha particle is traveling with a velocity of V0. Mass of the alpha particle, let it be m. Okay. So therefore initial kinetic energy half m V0 square. That's all, no? Initial potential energy 0, because they are present at a very large distance, no? There is no potential energy initially, 0. Okay. So final kinetic energy, Sima, listen very carefully. When alpha particle starts coming towards this nucleus, force of repulsion will increase, no? Ee rendu repel avadam start avutayi kada. So velocity of alpha particle continuously reduces. And when it reaches to this position, here its final velocity will be how much? 0. It will be temporarily in rest position. Then again it will travel in the opposite direction. Are you able to understand, ma? Therefore what will be its final velocity? 0. Final kinetic energy is also 0. Are you able to understand? Now they are present at a distance of r0. Okay, ma? Therefore what is the potential energy? So potential energy between two charges is given by K Q1 Q2 divided by R. This is the formula. This we will study in electrostatics. Okay, ma? When two charges are present at a separation of R, then what is the formula for potential energy, ma? K Q1 Q2 divided by R. That is the form. Are able to understand? Or you can write, if you want to write magnitude wise, it is minus K Q1 Q2 divided by R. If you want to write sign symbol also. Okay, ma? Now same formula I will apply here also. So I will take only magnitude plus potential energy K. K means what here? K means 1 by 4 pi epsilon naught. K is a constant. Are able to understand, ma? So write down. So 1 by 4 pi epsilon naught. Q1 is what? Q1 is charge of alpha particle. No? What is charge of alpha particle? 2e. Okay, ma? Multiplied by Q2. Q2 means charge of nucleus. What is the charge of nucleus? Z into E divided by R square. R means here a distance of closest approach. No? Distance of closest approach is R naught. Are you able to understand? So therefore, what is the final answer I got? So half m V naught square is equals to 2z E square divided by 4 pi epsilon naught into R naught. And I want R naught only, no? Distance of closest approach. And what is meant by distance of closest approach? So what is the minimum distance by which this alpha particle can reach the nucleus? Definitely alpha particle cannot go and collide with this one. Alpha particle will collide cheyaledu. Endukala? Because very strong force of repulsion will be there. No? Collision is not possible. So it will travel only up to certain distance. And that minimum distance where velocity of alpha particle will become 0, that is called as distance of closest approach. Understood now? So therefore R naught is how much? So 2z E square divided by 4 pi epsilon naught into half m V naught square. Okay, ma? And this is the equation which you are supposed to remember. So this is the distance of closest approach in the case of Rutherford. We are studying about the second calculation, which is called as impact parameter, calculated by Rutherford. Clear, ma? So derivation is not required for this one, just equation we will write down. So what is meant by impact parameter, ma? So this is for the case of deflecting electrons. See, ma, sorry, not deflecting electrons, ma, deflecting alpha particles. Okay, see, ma, when alpha particle is coming in a straight line to the nucleus, then it will retrace the path. So nucleus to head-on collision jarigindi, collision in one dimension. Then this alpha particle will retrace the path. But some alpha particles, they will be away from the nucleus also, no, by a perpendicular distance of b. That perpendicular distance is nothing but impact parameter. Okay, ma? So if alpha particles come like this, continuously this alpha particle will be repelled by this nucleus, no? So they start deviating. Okay, ma? And what is the final deviation? Final deviation is theta. Then for producing this much amount of theta, what is the perpendicular distance from the nucleus? That is called as impact parameter. And it is given by this relation. Z is square cot theta by 2 divided by 4 pi epsilon naught into half m v square. Okay, ma? Theta is the deflection of this alpha particle. M is the mass of the alpha particle. V is the initial velocity of the alpha particle. That's it. Clear, ma? Make a note up to here. So these are the calculations which were done by Rutherford. Okay. See, ma, here. So next calculation is calculation of energy of a rotating electron in any orbit. Okay, ma? See, ma, rotating electron, it will have two types of energies. So what are the two types of energies? Because of rotation, it will have kinetic energy. Because of velocity, it will have some velocity. No, electron will be rotating with some tangential velocity. Because of the tangential velocity, it will have kinetic energy. Similarly, this electron and nucleus, they are separated by some distance. No? If two charges are separated by some distance, they will have some potential energy also. So electron will have two types of energies, potential energy as well as kinetic energy. Let us see how we can calculate potential energy. First of all, kinetic energy. See, but this is an electron which is moving in a particular orbit. Let orbit is nth orbit. Nth orbit means first orbit, second orbit, third orbit, anything, nth orbit. And let us consider it is moving with a velocity of v naught. Are you able to understand, ma? So what is the radius of that nth orbit? Radius of that nth orbit, I will call it as Rn. Okay. And nucleus is responsible for providing centripetal. Now see. So therefore, this electron is able to rotate in circular path only because of centripetal force. No? And who is providing centripetal force? Centripetal force never provides చేస్తున్నారు, force of attraction between nucleus and the electron. So this force is providing centripetal force. Are you able to understand, ma? And what is the equation for force between two charges? 1 by 4 pi epsilon naught q1 q2 divided by r square. That is the formula number in electrostatics you should have studied. So charge of electron E, charge of nucleus Z into E, distance between them Rn square. Formula for centripetal force mv square by r. This is the formula. Okay. So therefore what I will do, one Rn and one square I will cancel. Okay. Therefore what I will get, so mv Rn square is equals to 2z. There is no 2z no here. So z is square divided by 4 pi epsilon naught into Rn. This is what I will get, Toma. Are you able to understand? So this is the equation I got. Now multiply, if I multiply both sides by 1 by 2, then what will happen? 1 by 2 multiplied by mvn square is equals to 1 by 2 multiplied by z is square by 4 pi epsilon naught into Rn. If I write like this. Why I am multiplying by 1 by 2? Because this converts into kinetic energy, no? Half mv square is the equation of kinetic energy, no? So therefore, kinetic energy of electron in which orbit? In nth orbit is how much? It is equals to z is square divided by 8 pi e naught into Rn. Okay, ma? So that is the equation of kinetic energy of an electron. Arthamaindi ela chesamu? Clear, ma? So the force of attraction between nucleus and the electron, they are providing the centripetal force. Okay, so F is equal to Fc. And what is the formula of force of electrostatic force? 1 by 4 pi epsilon naught q1 q2 divided by r square. This is the formula number. Clear, no? So therefore this is the equation which I got. Okay. Well, no? So in Rutherford's model, kinetic energy we have calculated. So the force of attraction between the nucleus and the electron, it is providing the centripetal force mv square by r. So r and 1 r get cancelled. Clear, nama? Then if I multiply by 1 by 2, then this is the equation of kinetic energy. Z is square divided by 8 pi epsilon naught into r. Equation of kinetic energy. Now how can I calculate potential energy? See, ma, here this is an electron, this is the nucleus. Charge of electron is E and charge of nucleus is Z into E. That may be any nucleus, gold nucleus, anything, any nucleus. Are you able to understand? So therefore, what is the formula of potential energy between two charges? That is minus k q1 q2 divided by r. Or just you can write k q1 q2 divided by r. Minus value we will write afterwards. See, ma. So potential energy is equals to k. What is the charge of electron, ma? Charge of electron is minus e. Now here we are writing minus instead of here. Are you able to understand? And what is the charge of second charge? Second charge is nucleus, no? What is the charge of nucleus? Z into E. And what is the distance between them? Distance between them is r, or Rn also you can call. Okay, ma? So therefore, what is the equation of potential energy and what is meant by k, ma? K means 1 by 4 pi epsilon naught. So substitute here. So minus z is square divided by, instead of k I can write 4 pi epsilon naught multiplied by r. So this is the equation for potential energy of the electron. Okay. Kinetic energy is this much. Z is square divided by 8 pi epsilon naught into r. Potential energy is this much. Minus z is square divided by 4 pi epsilon naught into r. So what is the difference between both of them? E energy ki difference ఏముంది చెప్పండి. First of all, this is positive energy, that is negative energy. Here I have z square, here also I have z square. Here I have 8 pi epsilon naught r, here I have 4 pi epsilon naught into r. Clear, no? So if I want to calculate total mechanical energy, total mechanical energy is the sum of what? It is the sum of kinetic energy plus potential energy. Kinetic energy is how much? Kinetic energy is Z is square divided by 8 pi epsilon naught into r. And what is the kinetic potential energy? So minus ZE square divided by 4 pi epsilon naught into R. Okay, ma? So if I do this total calculation, what I will get is I will get minus ZE square divided by 8 pi epsilon naught into R. So this is the equation which I will get. Are you able to understand? So equation of kinetic energy, equation of potential energy, equation of total energy. Now let us write relations between them. See ma, here also I have ZE square by 8 pi epsilon naught R, no? And here also exactly same value I have, but just a sign is different. Okay, so therefore I can write a relation between total energy and kinetic energy. Total energy is just, it is negative of kinetic energy. Very 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 important relations. వీటి పైన చాలా సార్లు బిట్లు వచ్చినాయి. What is the relation between total energy of particle and kinetic energy of the electron rotating around the nucleus? This is the relation. Similarly, if you see relation between potential energy and kinetic energy, what is the relation? Again minus is one difference, and here potential energy denominator is 4. It means when compared to kinetic energy, its value is double. Clear? So therefore what I can write, potential energy is equals to minus 2 times of kinetic energy. I can write a relation like this also. Are you able to understand, ma? So it is minus 2 times of kinetic energy. Okay. Similarly, if I want a relation between potential energy and total energy, then how can I write? Potential energy and total energy. Here also when compared to this one, this is double, no? Clear? So therefore I can write potential energy is 2 times of total energy. No need of writing minus here, because this is also minus symbol, this is also minus symbol. Understood, Dhamma? So these 3 relations you must always remember. Are you able to understand? Clear, ma? Now here the question is that what is meant by negative sign and what is meant by positive sign? See ma, potential energy minus ZE square, no? Total energy is also in negative terms. Now the question is, what is meant by negative? Negative term means what? No. Negative term means it indicates that this particular electron, it is present under the influence of nucleus, or we can say this electron is bound to the nucleus. Until you give positive energy, electron cannot go out of this orbit. Adi danartham. Are you able to understand, ma? Negative sign of any energy represents that it is under the force of attraction. Negative symbol, attraction. Understood, no? It means that particular electron, it is present under the influence of that nucleus. So if you want to remove that electron from that orbit, what you have to do? You have to add positive energy. Meer ye energy ni ivvali? Positive energy should be given. Okay? Then only I can remove electron from that particular orbit. Is it clear, ma? So write that point. So therefore what is the note point here? I have to write negative energy represents electron is under the attraction of nucleus. Or the same statement can be asked like this also. How can he ask the same statement? Negative energy represents, I will write here, ma. Clear? Completed now this one? Okay. So second note point, negative energy represents electron is bound to the nucleus, or you can say it is under the attraction of nucleus. So until positive energy is given, okay ma, electron cannot be removed. Electron cannot be removed from its orbit. That is called as negative energy. నెగిటివ్ ఎనర్జీ అంటే విషయం అర్థమైంది కదా. నెగిటివ్ ఎనర్జీ అంటే అది చచ్చినట్లు ఆ న్యూక్లియస్ చుట్టూ తిరుగుతూనే అంటే అప్పు ఉంది అని అనుకోండి. సుప్రజ నాకు ₹1,00,000 అప్పు ఉందన్నమాట. నేను చెప్పిన పనులన్నీ చేస్తూ ఉండాలి. అట్లా ఎలక్ట్రాన్ కూడా న్యూక్లియస్ కప్పు ఉంది అనుకుందాం, మర్యాదగా దాని చుట్టూ అది తిరుగుతూ ఉండాలి. రేపు అండర్స్టాండ్. అప్పు తీర్చేయాలంటే ఏం చేయాలి? ఎవడన్నా బయట నుంచి వచ్చి దానికి డబ్బు ఇచ్చి కట్టుకోరా అని చెప్పాలి. ఎలక్ట్రాన్ కూడా ఎవడో బయట నుంచి ఎనర్జీ ఇస్తే కానీ అది న్యూక్లియస్ నుంచి బయటికి రాలేదు. దట్ ఈస్ ద మీనింగ్ ఆఫ్ నెగటివ్ ఎనర్జీ. అండర్స్టూడ్ నామా? దట్స్ ఇట్. ఓకే, సో దిస్ ఈస్ ద టోటల్ ఎనర్జీ నామా, minus Z² divided by 8πε0 into R. So if I give same amount of positive energy, ఇంతే పాజిటివ్ ఎనర్జీ ఇస్తే then total energy will become zero, no? Are you able to understand? Then only I can take that electron out of the atom and electron travels up to infinity. It means it moves out of the attraction force of that particular nucleus. Okay? For example, if this energy is minus 10 joules, so to remove this electron permanently out of atom, how much energy I have to supply? Plus 10 joules energy I have to supply. Understood now? Same concept we studied in chemistry also. Ionization enthalpy. What is meant by ionization enthalpy? Positive ionization enthalpy, negative ionization enthalpy. Positive ionization enthalpy means you have to supply energy to remove the electron. Clear? Negative ionization enthalpy means if you remove the electron, atom will release the energy. That is called positive and negative. Clear? That's in Rutherford's model, scientists have a concern, no? They have some question to Rutherford which he could not answer. What was the question put forward by the people to Rutherford? If electron is revolving continuously, it should emit energy continuously and electron should fall on the nucleus. Are you able to understand, ma? So that concept was overcome by Niels Bohr model. That disadvantage, that drawback in Rutherford's model, it was overcome by Rutherford's model. So he introduced the concept of stationary states or stationary orbits. Yeah, concept e marchesnadu anamata. Em cheppinadu? So orbits are like stationary states or stationary orbits. Unless electron is present in the same orbit, it doesn't lose energy, it doesn't gain energy. Simple ga concept e teesesnadu anamata. Enduku anedi cheppaledu, cheppinadu ante. Clear nama? So therefore, what is the first postulate of Niels Bohr model, ma? First postulate is that electrons revolve in stationary orbits or stationary states. Okay, so until electron is in same orbit, it doesn't lose energy or gain energy. Are you able to understand, no? It doesn't lose energy, it doesn't gain energy. Second point, if electron should move to higher orbit, then it should absorb the energy difference between orbits and vice versa. What is meant by vice versa? If electron should go to higher orbit has higher energy. Orbit perige koddi energy of electron perugutu veltundi. Are you able to understand, ma? So if it should travel to second orbit to third orbit, then it should absorb the energy difference between those two orbits. Okay. Similarly, if it wants to travel from second orbit to first orbit, then what it has to do? It has to release energy. How much energy? Energy equal to energy difference between both the orbits. That was the second statement given by Niels Bohr. So therefore we can say that, for example, clear, ma? This is the nucleus, this is the first orbit, second orbit, and consider this is the third orbit. Are you able to understand? Consider here there is an electron. So energy of first orbit is E1, energy of second orbit is E2, energy of third orbit is E3. Definitely E3 is greater than E2 is greater than E1. Clear, no? So if electron should travel to third orbit, then here it should absorb energy. Okay. Same electron, if it should come to first orbit, it should release energy. Understood, Nama? So if electron should travel from first orbit to second orbit, then E2 minus E1 is equals to hc by lambda or h nu. So this much amount of energy should be absorbed. Okay, and it should travel from second orbit to first orbit. Then again E2 minus E1 is equals to hc by lambda is equal to h nu. This much amount of energy should be released. Okay, ma? కింది నుంచి పైకి వెళ్ళాలంటే ఎనర్జీ కావాలి, దానికి పై నుంచి కిందికి రావాలంటే ఎనర్జీని రిలీజ్ చేయాలి. అండర్స్టూడ్? అండ్ వాట్ ఈస్ ద ఈక్వేషన్ ఆఫ్ అండ్ ఎనర్జీ మీన్స్ వాట్ కైండ్ ఆఫ్ ఎనర్జీ? Light energy, heat energy, whatever it may be. Are you able to understand, ma? And hc by lambda. Lambda is the wavelength of that radiation. Nu is the frequency of that radiation. Okay, ma? Lambda means what here? Wavelength of radiation. Nu means frequency. Same. This much amount of energy should be absorbed. Same amount of energy should be released. Different sound వస్తున్నాయి ఇంట్లో. So this is the second postulate of Niels Bohr model. Okay. Third postulate is that electron can revolve only in that orbit where its angular momentum is integral multiple of nh by 2 pi. Okay, ma? Here h is called Planck's constant, ma. H is called Planck's constant, whose value is 6.62 into 10 power minus 34 joule second. That is the value of Planck's constant. Understood, no? So what is the third postulate, ma? Electron you cannot find wherever it wants. It can be present in only particular orbits. In which orbit? Where its angular momentum is exactly the integral multiple of nh by 2 pi. Only in such orbits only you can find the electrons. What is meant by angular momentum? In rotational dynamics we studied, no? Angular momentum is mvr. That is angular momentum, no? Integral multiple of nh by 2 pi, h by 2 pi means what? Integral multiple of h by 2 pi. So nh by 2 pi, where n values are 1, 2, 3 like this. So this is number of orbit. Are you able to remember? N is called what? Number of orbit. So in first orbit you have to place n value is 1 h by 2 pi. Angular momentum of that electron will be that much. Are you able to understand? In second orbit 2h by 2 pi. Third orbit 3h by 2 pi. So when angular momentum of electron is equal to nh by 2 pi, only in that particular orbit only you can find the electrons. In other places you cannot find the electrons. So these are the postulates which were given by Niels Bohr. అర్థమన్నాయి కదా? So electrons can revolve only in stationary orbits where they cannot lose energy, they will not gain energy. Only if they want to go to another orbit, then only they will either absorb energy or release energy. And where you can find the electrons? Only where their angular momentum is equals to nh by 2 pi, there only you can find the electrons. And those positions where you find electrons, they are called as orbits. Clear? That's it. Niels Bohr. First one is radius of nth orbit. Okay, ma? Now see, ma, this is a nucleus and somewhere electrons are rotating around this nucleus. Okay. So this electron, let us consider it is present at a distance of Rn. Rn means radius of nth orbit. N may be 1, 2, 3, 4, anything. Okay, ma? Nth orbit. Okay. So on this electron, if mass of the electron is m, who is providing the centripetal force? Centripetal force is provided by electrostatic force of attraction. Already we studied no? Centripetal force ni evaru provide chestunnaru? The force of attraction between nucleus and the electron. Are you able to understand? No? See, my electron always it is trying to move in a straight line. Ade kada manam study chesindi. Electron is always trying to move in a straight line. But because of the force of attraction, continuously a centripetal force is provided. And because of that centripetal force, it is moving in a circular path. Okay. So what is the equation for centripetal force? mv square divided by r, where v is the tangential speed of this electron. Okay. And this is provided by electrostatic force of attraction between two charges. What is the electrostatic force of attraction? 1 by 4 pi epsilon naught multiplied by E into ZE divided by Rn square. E is the charge of electron, ZE is the charge of nucleus, Rn is the distance between them. This is the equation to calculate force of attraction or repulsion between two charges. 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Understood, Noma? Now see. So therefore, this is one calculation. Let it be my first equation. And according to Niels Bohr, mvr is equals to nh by 2 pi. This equation is also there, Noma? mvr is equal to nh by 2 pi. Angular momentum of an electron is equal to the integral multiple of h by 2 pi, nh by 2 pi, 1h by 2 pi, 2h by 2 pi, 3h by 2 pi. Are you able to understand? So what I will do is, I will square this on both sides. If I square on both sides, what I will get? So m square v square Rn square is equals to nh divided by 2 pi whole square. This is my second equation. Are you able to understand? No? So then what I will do is, I will divide the second equation by first equation. Okay, ma? If I start a division, then m square v square Rn square is equals to n square h square divided by 4 pi square divided by, here what I have, here I have m v square divided by, here instead of capital R, I can write Rn. Okay, ma? So m v square divided by Rn divided by 1 by 4 pi epsilon naught ZE square divided by Rn square. Understood, Nama? Now let us see what are the terms which can be cancelled. So here m and square will get cancelled, velocity and velocity will get cancelled. Okay, ma? So Rn square multiplied by Rn, still what I have multiplied by m is equals to n square h square divided by 4 pi square multiplied by 4 pi epsilon naught into Rn square divided by ZE square. Okay. So this is the relation which I got. Okay, ma? So see, ma, we should not do any mistakes, otherwise everything will be gone. So Rn square and Rn square will get cancelled, 4 and 4 will get cancelled, square and pi will get cancelled. Clear now? So therefore I am left with Rn is equals to n square h square epsilon naught divided by m pi z e square. Okay. So therefore here what are the variables? N is a variable, no? N is number of orbit. And still what are the variables? Z, atomic number, is also a variable. It depends on the atom, no? Z value depends on the atom. So you take them outside. So therefore I can write, so h square epsilon naught divided by pi m e square multiplied by n square divided by z. I can write like this. Are you able to understand, ma? So this is the equation to calculate radius of the nth orbit. Understood, no? So h square epsilon naught square divided by pi m e square divided by n square by z. Okay. Now if you substitute all these values, so h square epsilon naught divided by pi m e square. Okay ma, what is meant by h value? Planck's constant, no? 6.624 into 10 power minus 34 whole square. Epsilon naught is 8.854 into 10 power minus 12 divided by pi value is 22 by 7. Mass of electron is 9.1 into 10 power minus 31 multiplied by charge of electron is 1.6 into 10 power minus 19 joules, 19 whole square. Okay ma? So if I substitute all these values, then what I will get is, I will get 0.53 angstrom. This is what I will get, 0.53 angstrom. Why I am writing 0.53 not angstrom, just 0.53. This is the value which you will get. Okay, or you can write 0.53 into 10 power minus 10. Okay, 10 power minus 10 can be written as angstrom, no? So 0.53 angstrom, you can write like this. Understood, no? Now instead of this h square epsilon but not by pi m e square, you can substitute 0.53 angstroms, no? So therefore what is the next calculation I can do? So therefore Rn is equals to 0.53 n square by z angstrom. Okay ma? So you can write like this also. Okay, understood now ma? Now when you look at this equation, one thing which I can understand is that radius of nth orbit is directly proportional to n square. I can get that observation, no? Radius is proportional to what? Radius is proportional to square of the orbit. Are you able to understand, no? Therefore questions were asked previously many times on this relation also. Therefore what I can write, R1 is to R2 is to R3 dash 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 is equals to 1 is to 4 is to 9 is to 16, and it goes on like this. Okay, it means if radius of first orbit is 1 unit, radius of second orbit will be 4 times bigger. Radius of third orbit will be 9 times bigger when compared to first orbit. Radius of fourth orbit will be 16 times bigger when compared to first orbit. Understood, no? Orbits are equal ga arrange ayi undavu. First orbit radius is very small, second orbit is bigger, third orbit is very bigger, fourth orbit radius very bigger. Okay, or if you want to draw a diagram approximately, so this is the radius of first orbit, second orbit radius will be bigger, third orbit very much bigger, fourth orbit very much bigger. So like this the electrons will be arranged, because they are in the ratio of 1 is to 4 is to 9 is to 16. Understood, Dhamma? So therefore if I want to calculate for hydrogen, because all these calculations they are satisfied only for hydrogen. Clear? For hydrogen what is Z value? Z value is 1. Hydrogen atomic number 1. So Z value is 1. So therefore Rn is how much ma? Rn is equals to 0.53 multiplied by n square angstrom. Okay ma? So R1 is how much? 0.53 into 1 square, which is equals to 0.53 angstrom. Clear na ma? Radius of second orbit of hydrogen is how much? 0.53 into 2 square, which is equals to 2.12 angstrom. Radius of third orbit of hydrogen is how much? 0.53 into 3 square, which is equals to 4.77 angstrom. So like this you can go on doing the calculations. Understood, no? That's about the first calculation of Niels Bohr, which is called as radius of nth orbit. Okay ma? And they are satisfied only for hydrogen. So these are the radiuses of hydrogen. First orbit of hydrogen will have this much radius, second orbit this much, fourth orbit this much, sorry, third orbit. Like that you can calculate. Okay ma? Basic formula is this one, 0.53 n square by z. Understood, no? And it is measured in what? Not meters, it is measured in angstrom. 1 angstrom means how much ma? 10 power minus 10 meters. Understood, no? 1 angstrom is equal to 10 power minus 10 meters. That's it. Okay. నీటిలో ఈక్వేషన్స్ పైన డెప్త్గా అడగకపోవచ్చు, మెయిన్స్లో అయితే అడుగుతారు. నీటిలో అడిగితే ఆశ్చర్యపడాల్సిన అవసరం లేదు, ప్రాబబిలిటీ చెప్పలేము. సో బై హార్ట్ చేయాల్సిందే ఈక్వేషన్స్. క్లియర్మా? సో సీమా. So next calculation of Niels Bohr was velocity of electron in nth orbit. Well, electron is rotating with how much speed? Understood, Nama? And we know this relation, Nama. Angular momentum of an electron is equals to mvr is equals to nh by 2 pi. Is equals to nh by 2 pi. So therefore, what is the velocity of electron in nth orbit? Okay, ma? nh divided by 2 pi m into Re. Just m into Rn I have taken to that side. So therefore Rn equation already we have written, no? So substitute that equation. So velocity of electron in nth orbit is equals to nh divided by 2 pi m multiplied by, and what is the equation for radius of electron in radius of nth orbit, ma? So n square h square epsilon naught divided by pi m z e square. Okay. So velocity of electron in nth orbit is equals to nh multiplied by pi m z e square divided by 2 pi m multiplied by n square h square multiplied by epsilon naught. Okay. Now see what are the terms which can be cancelled, ma? So one n and one square will get cancelled, one h and another square will get cancelled. So pi m will get cancelled. Clear, no? So therefore what I am left with, still anything to cancel? No. So therefore velocity of electron in nth orbit is how much, ma? Z e square divided by 2nh epsilon naught. This is the equation. Okay, ma? So Vn is equals to e square by 2 e naught n into h. So this is the equation to calculate velocity of electron in nth orbit. Are you able to understand, ma? So therefore here one point which I can understand is that velocity of electron in nth orbit is inversely proportional to n, ma. N means number of orbit, no? Okay, ma? It means as number of orbit increases, what happens to velocity of electron? Velocity decreases. Clear, no? So therefore velocity of electron in first orbit is highest. ఫస్ట్ ఆర్బిట్లో ఎలక్ట్రాన్ పిచ్చి కుక్కలాగా ఫాస్ట్గా తిరుగుతూ ఉంటాం, వెరీ ఫాస్ట్లీ ఇట్ విల్ బి రొటేట్. సెకండ్ ఆర్బిట్ పోయే లోపల కొంచెం తగ్గుతుంది స్పీడ్, థర్డ్ ఆర్బిట్ పోయే లోపల ఇంకా కొంచెం తగ్గుతుంది. వాట్ ఈస్ ద రీజన్? రీజన్ ఈజ్ ఫోర్స్ ఆఫ్ అట్రాక్షన్ ఆల్సో రెడ్యూసెస్, నో? ఫోర్స్ ఆఫ్ అట్రాక్షన్ ఆల్సో రెడ్యూసెస్. సో న్యూక్లియస్ కెనాట్ ప్రొవైడ్ హ్యూజ్ అమౌంట్ ఆఫ్ సెంట్రిపిటల్ ఫోర్స్. ఎక్కువ స్పీడ్తో రొటేట్ అవ్వాలంటే ఎక్కువ సెంట్రిపిటల్ ఫోర్స్ ఉండాలి. ఇఫ్ ఎలక్ట్రాన్ షుడ్ రొటేట్ విత్ మోర్ స్పీడ్, సెంట్రిపిటల్ ఫోర్స్ ఆల్సో షుడ్ బి గ్రేటర్. But as the distance increases, centripetal force decreases, no? So electron also rotates very slowly. It means somebody is setting the electron there with required velocity. ఒక ఆర్బిట్లో సెట్ చేయడం కాదు, ప్రతి ఆర్బిట్లోనూ ఎంత వెలాసిటీ కావాలో అంతే వెలాసిటీతో ఎవరో సెట్ చేసినారనమాట. దెన్ ఓన్లీ ఇట్ ఈస్ రివాల్వ్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? దట్స్ ఇట్. క్లియర్, మా? సో దేర్ ఫోర్ నౌ ఇఫ్ ఐ డూ ద క్యాలిక్యులేషన్ ఫర్ hydrogen. For hydrogen atom if I calculate, then Z value will be 1, no, for hydrogen. Z value will be 1. So velocity of electron in nth orbit is how much? E square divided by 2 epsilon naught n into h. Okay. Now again if I substitute all these values, I will get V is equals to C divided by 137 n, where C is called as speed of light. C is called as what? Speed of light. Okay, ma? And n value is number of orbit. Okay. Therefore velocity of electron in first orbit is how much? C by 137. Velocity of second orbit is how much? 2 into 137. Velocity of third orbit how much? C divided by 3 into 137. Like this. Understood, no, ma? Okay. And all the calculations we have done in SI units, no? So meters per second, meters per second, meters per second. Okay. So what is the speed of light? 3 into 10 power 8. చిన్న స్పీడా పెద్ద స్పీడా? ఎక్కువే. నీకంటే ఎక్కువనా కదా? స్పీడ్ ఆఫ్ లైట్ ఈస్ ద హైయెస్ట్ స్పీడ్ పాసిబుల్ ఇన్ దిస్ యూనివర్స్. ఓకే. అంతకన్నా ఫాస్ట్గా దేవదూతలు తప్ప ఎవరు పోలేరు ఇంకా. Speed of light is 3 into 10 power 8, which is the highest possible speed in the universe. Understood, Nama? So C by 137. ఇది కూడా చిన్నదా చాలా పెద్దగా ఉంటుంది అది కూడా. C by 137 is also a very big speed. So according to this calculation, electron is rotating around the nucleus with a very large speed. చాలా ఎక్కువ స్పీడ్తో రొటేట్ అవుతుంది. Are you able to understand? That's it. So this is the velocity of electron in first orbit in hydrogen, second orbit, third orbit. So velocity is continuously reducing, Noma. That's it. Okay. So our next calculation is frequency of electron in nth orbit. What is meant by frequency, ma? Frequency means what? Frequency ante how many oscillations the electron is making in 1 second. ఒక సెకండ్ లోపల ఎలక్ట్రాన్ ఎన్నిసార్లు తిరుగుతుంది న్యూక్లియస్ చుట్టూ. దట్ ఈస్ కాల్డ్ as frequency, no? The number of rotations the electron make in 1 second is called as frequency. Let us do the calculation and we will be shocked to see the frequency of this electron. Okay, ma? See, ma, when electron is moving like this, its tangential speed is given by omega into r only, no? V tangential is equals to omega into r. Omega is angular frequency, which can be written as 2 pi f. R is radius of nth orbit. Radius of nth orbit. Clear, number? So what is frequency? V tangential divided by 2 pi into r. Okay. V tangential already we have calculated, no? V tangential means velocity of electron. Velocity of electron, what is the equation? Z e square divided by 2 e naught n into h. Substitute here. So therefore frequency is equals to V tangential Z e square divided by 2 epsilon naught n into h multiplied by r n. Okay, ma? So you can write like this. This is one form of equation. And we have one more equation for r n also, no? Radius. 2 Z e square divided by 2 e naught n into h multiplied by 2 pi into r n. This is the equation. Are you able to understand, ma? So, and one more equation we have r n also, no? What is the equation for r n? N square h square epsilon naught divided by pi m z e square. That also you can substitute. Are you able to understand, ma? Then you will get another equation. But I don't have patience to write that equation. You only write down. Okay, ma? I will write down finally for hydrogen. Okay. So for hydrogen, the frequency of electron in first orbit is 6.57 multiplied by 10 power 15 rotations per second. So this was the calculation done by Niels Bohr. Okay, ma? So in hydrogen, in the first orbit, electron is making how many rotations, ma? 10 power 15 rotations. 10 power 15 అంటే ఎన్నిసార్లు? 10 power 7 అంటే 40 సార్లు అని కదా. 10 power 8 అంటే 10 కోట్లు. 10 power 9 అంటే 100 కోట్లు. 10 power 15 అంటే ఇంకా దాన్ని ఏమంటారో మనకు తెలియదు. సో దీస్ మెనీ రొటేషన్స్ ఇట్ ఈస్ మేకింగ్ ఇన్ 1 సెకండ్. ఏది? ఎలక్ట్రాన్. క్లియర్ మా? సో ఆబ్వియస్లీ మోర్ స్పీడర్ దాన్ మై సెల్ఫ్ ఆల్సో. నాకంటే చాలా స్పీడ్. క్లియర్ మా? సో దిస్ ఈస్ అబౌట్ ఫ్రీక్వెన్సీ ఆఫ్ ఎలక్ట్రాన్ ఇన్ nth orbit. Are you able to understand? Come on, make a note up to here. So the fourth one of Bohr's postulates, Bohr's calculation is energy of electron. So kinetic energy and potential energy, these relations already we have calculated in Rutherford's model. Same equations here also, same as in Rutherford's model. So we know that total energy is equals to kinetic energy plus potential energy, and this is also same. But we have equation for Rn, radius of electron in nth orbit. So that equation is this one, n square h square epsilon naught divided by pi m z e square, that we are substituting here, and this is the final equation which we are getting, equation for total energy. Okay. So here questions were asked on this relation previously sometimes. How questions were asked? So total energy was depending on e to the power of what? Okay. Total energy is depending on e to the power of 4. Okay. Total energy was depending on mass how many times? So total energy is directly proportional to m power 1. Okay. So like this questions can be asked. Total energy depends on the reciprocal of epsilon naught square or inversely proportional to epsilon naught square. So questions were asked like this. Okay. So therefore, here what are the variables? Z and n, they are variables. Z is the atomic number, n is the number of orbit. These are the variables. Now remaining all these values, they are constants. E value, charge of electron, mass of electron, epsilon naught square, and h is Planck's constant. So if I substitute all these values, then this is the value of this is the total value which I will get. Able to understand, ma? So in terms of joules, what is the value I will get? In terms of joules, I will get 21.7 into 10 power minus 19 joules of energy. And we know how to convert joules into electron volts. No? 1 electron volt is equals to 1.6 into 10 power minus 19 joules. Clear? So if I convert this joules into electron volts, then it converts into 13.6 electron volts. Are you able to understand? So therefore, instead of this total value, I can write this 13.6. So therefore, what is the equation for total energy of an electron revolving in nth orbit? It is minus 13.6 z square divided by n square. This is a very important relation. Are you able to understand? So therefore, now if I do the calculation only for hydrogen atom, okay, ma? So if calculations are done for hydrogen atom, how can I say? So for hydrogen atom, Z value is 1, Z value is 1. So therefore, what is the equation for total energy, ma? So it is minus 13.6 divided by n square electron volts. Clear? So therefore, now you can calculate for first orbit. For first orbit, n value is 1, no? So therefore, total energy is how much? Minus 13.6 divided by 1 square. It is minus 13.6 electron volts. Okay, ma? Similarly, energy of electron in second orbit is how much? Minus 13.6 divided by, this is first orbit, this is second orbit. So divided by 2 square. So how much might is? Minus 13.6 divided by 4. It is nearly minus 3.4 electron volts. Clear, no? Similarly, total energy for third orbit is how much? Minus 13.6 divided by 3 square. So minus 13.6 divided by 9, it is nearly minus 1.51 electron volts. Clear? Similarly, total energy in the case of fourth orbit is equals to minus 13.6 divided by 4 square, which is equals to minus 13.6 divided by 60. So it is approximately minus 0.84. Okay. So like this, you can go on do the calculations for to calculate energy of any orbit. Are you able to understand, ma? So total energy of first orbit is minus 13.6. Total energy of second orbit minus 3.4. Third orbit minus 1.51. And fourth orbit it is minus 0.84. Are you able to understand? So now the question is, when orbit number increases, if I am traveling to second, third and fourth, energy of the orbit is increasing or decreasing? But they are decreasing, no? 13.6, 3.4, minus 1. They are negative values, no? So magnitude wise they are decreasing, but it is negative value. So therefore we can say that total energy continuously increases. Energy of second orbit is greater than energy of first orbit. Energy of fourth orbit is greater than energy of third orbit. Are you able to understand? Because continuously energies are increasing. Are you able to understand? So make a note up to here. Completed number this one. Therefore what I write? Therefore I write that, clear, ma? As number of orbit increases, clear, ma? So energy also increases. Energy also increases. And one more note point is that, second note point is, clear, ma? So as number of orbit increases, energy difference continuously decreases. Energy difference continuously decreases. What is the meaning of this one? Sigma. So you take first orbit, it is minus 13.6, no? second orbit minus 3.4. So 13.6 minus 3.4 is how much? Nearly 10.2. Okay. So energy difference between first orbit and second orbit is 10.22 electron volts. But if you see the energy difference between second orbit and third orbit, it is very less. 3.4 minus 1.5, very less. Clear, no? Approximately some 1.9, like that you will get. Similarly, energy difference between third orbit and fourth orbit, it is still very less. So 1.5 minus 0.84. Okay, ma? Approximately how much? 0.66, like that. Okay. Similarly, if you take energy difference between fourth orbit and fifth orbit, it will be still very less. Clear, no? So therefore, what we understand, as number of orbit increases, energy difference continuously decreases. Only energy difference between first orbit and the second orbit is very large. Remaining energy differences continuously decreases. So therefore, if I draw the diagram of energy differences, so here if energy is taken on the y-axis, then graph I can draw like this. Clear, Nama? So this is the energy of first orbit, energy of first orbit. Then energy of second orbit difference is very less, no? See, this gap is very large. This gap becomes very less. This is the second orbit energy. What about third orbit energy? Third orbit energy will be still very less. Okay? This is the third orbit. And fourth orbit energy will be still, it will be very, very, very less. So question was asked on this graph also previously. Are you able to understand, ma? Orbits perige koddi energy differences emavutayi taggutu veltayi. Okay? Energy difference only between first and second orbit is very large. For remaining calculations, as number of orbit increases, energy difference continuously decreases. And if you draw energies, it will be like this. So first one minus 13.6, okay, ma? Second one is minus 3.4. Third one is minus 1.51. Energy difference tagipotundi kada. That is a very important point. Clear, ma? So see, when electron, if it wants to move from lower orbit to higher orbit, it should gain energy. Similarly, when it should return from higher orbit to lower orbit, it should lose energy. And energy is lost or energy is gained in the form of radiation only, no? In the form of electromagnetic radiation. Okay, ma? So energy is lost or gained in the form of what? In the form of radiation. Okay, ma? So radiations are electromagnetic in nature. So therefore, the wavelength of that radiation wavelength of the radiation 1 by lambda is equals to RH into 1 by n1 square minus 1 by n2 square. This is the relation. Clear now? So the wavelength that is received by the electron or wavelength that is given out by the electron is given by this relation. 1 by lambda is equals to RH into 1 by n1 square minus 1 by n2 square. Clear now? So what is RH here? RH is called as Rydberg's constant. Rydberg's constant. Clear now? And its value is 1.07 into 10 power 7 m power minus 1. That is the value of Rydberg's constant. Clear now? Similarly, what is n1? n1 is the orbit to which electron is reaching. Okay, ma? N2 is what? Orbit from which electron is moving. Are you able to understand, ma? N1 means what? N1 means that orbit to which electron is finally traveling, and to N1 from where it will go, it will travel from N2. Okay, ma? So this is the destination and this is the point from which it is traveling. So this is N1 and this is N2. Okay. So based on this equation, we have some series observed by different scientists, and those series, they are called as series of electromagnetic spectrum. Are you able to understand? So series of electromagnetic spectrum. How many series are there? We have L, BP, BP. So So these many series were observed, and these are the names of the scientists who observed this series. Okay, so L stands for Lyman, B stands for Bohr, P stands for Pascal, this stands for bracket, and again P stands for fund. So these are the different series which are observed: Lyman series, Bohr series, Pascal series, bracket series, and fund series. Clear number? Now let us study each of them in detail. First one we will study about Lyman series. Okay, ma? So in Lyman series, N1 is 1, N2 can be 2, 3, 4, 5, anything. Now can you say what is meant by N1 is 1 and N2 is 2, 3, 4, 5? What is the meaning of this one, ma? What is the meaning of it? N1 is 1 means electron is returning to first orbit. Electron, N1 means that's what we have written, no? Orbit to which electron is reaching. ఒకసారి వింటే మళ్ళీ మీరు అప్లై చేసేయాలి. ఏం వింటా ఉన్నారు మీరు? బుర్రని కొంచెం పదును పెట్టండి. హరికథ విన్నట్టు వినకూడదు క్లాసులో. క్లాస్ వింటే బుర్ర వేడెక్కిపోవాలి, అట్లా వినాలి. సో N1 is the orbit to which electron is reaching. N2 is the orbit from which electron is reaching. It means electron finally reaches to first orbit. From which orbits? It may reach from second orbit also, it may reach from third also, fourth also, fifth also, sixth also, any orbit. Finally it should reach to which orbit? First orbit. That series is called as Lyman series. So in this process, some wavelengths will be released, you know, higher orbit nunchi lower orbit ki ravalante energy release avvali kada. So here also some energy will be released. And all these series of spectrum which are released, they will come under Lyman series. And what is the importance of this series? Every radiation, it will fall under ultraviolet region. Ultraviolet region ki oka wavelength untundi kada. So all the wavelengths in this series, they will fall under ultraviolet region. Are you able to understand, ma? So right. So all spectra released will fall under UV spectrum, or you can say UV region. So that series is called as Lyman series. Are you able to understand, ma? Similarly, second series what? Second series is Bohr series. Okay, ma? Bohr series. In Bohr series, N1 value is 2, N2 values are 3, 4, 5, and it goes on like this. It means finally electron is returning to which orbit? Finally electron is returning to second orbit. From which orbit it is returning? It may return from third also, fourth also, fifth also, sixth also. Clear number? See, here the energy difference is very large in Lyman series. Why energy difference is very large? Because the difference of energy between first orbit and second orbit is very large, no? Okay. So therefore the energy released is also very large. That is why that energy is very strong. It will fall under UV spectrum, which is comparatively a strong energy. Frequency is very large. Wavelength is very less. Are you able to understand? But here what is happening? Electrons, they are returning from 3 to 2. Energy difference between 3 and 2 is very less, no? Or even if it is returning from 4 to 2, then also less. 5 to 2, then also it is less. Are you able to understand, ma? So here the radiation released, falls under visible spectrum. And we know that UV spectrum is powerful, more energetic when compared to visible spectrum. Visible spectrum means the spectrum which is responsible for our vision. మనం చూడడానికి ఎవరు రెస్పాన్సిబుల్? విజిబుల్ స్పెక్ట్రమ్ ఈస్ రెస్పాన్సిబుల్. ఓకేమా? నెక్స్ట్ సిరీస్ ఈస్ Pascal series. Okay, ma? So in this series, n1 value is 3, n2 values are 4, 5, 6, and it goes on. Clear now? So here the spectrum falls under infrared region or infrared spectrum. Infrared. The next radiation to visible spectrum is infrared only. So which is having a very less energy. Okay. Next, bracket series. Bracket series, n1 value is 4, n2 values are 5, 6, 7, and it goes on like this. So this also falls under infrared region only. Are you able to understand, ma? So the next one is, I will write here, last one is fund series. Okay, ma? Fund series. So fund series, n1 value is 5, n2 values are 6, 7, and it goes on like this. So this radiation also falls under infrared spectrum or infrared region. Are you able to understand, ma? So these are the different spectrum which are observed when electron moves from one orbit to another orbit. Okay, and questions can be asked on them. వీటిపైన క్వశ్చన్స్ చాలా ఎక్కువ సార్లు వస్తూ ఉంటాయి. Clear? That's it. So these are the different calculations which were done by Niels Bohr. All these calculations are calculations of Niels Bohr. Okay, but this series were observed by these respective people. That is why their names are given on those scientists. Okay, make a note up to here. Okay, ma. So see, ma'am. So drawbacks of Niels Bohr model. Okay, ma. So he said that orbits are circular, no, ma. Just Rutherford's model was also same. But he could not explain why orbit should be circular, while elliptical orbits are also possible. Elliptical orbits lo kuda undachu kada electrons. So enduku circular lone unnai, he could not explain. Okay, ma. And he said that angular momentum is equals to nh by 2 pi. It is only integral multiples of nh by 2 pi. So other values are not possible. So first orbit h by 2 pi, second orbit 2h by 2 pi, third orbit 3h by 2 pi. Only that much amount of angular momentum is possible. Madhyalo values enduku possible kavu, he could not explain. Are you able to understand, no? And he could not explain these effects which are called as Zeeman effect and Stark effect. Zeeman effect and Stark effect means what? Electric lines and magnetic lines, they will split under some fields. So what is the reason for that splitting also he could not explain. So these are some of the drawbacks of Niels Bohr model. Are you able to understand? Make a note of it here. Okay. Broglie's explanation of quantization of angular momentum. Okay. Sima here, what Niels Bohr has said that angular momentum mvr should be integral multiple of nh by 2 pi. This is what he said, no, in the third postulates of Niels Bohr. But how this is possible, Niels Bohr could not explain. And this explanation was given nearly 10 years later. 10 సంవత్సరాల తర్వాత ఇది చెప్పినాడు అన్నమాట. So de Broglie said that. So de Broglie said that electron is behaving wave properties also. It is showing wave properties also. So de Broglie was the person who said that matter and radiation, they are not different, they are one and the same. Are you able to understand, ma? Matter is a form of energy. Radiation is also a form of energy. Radiation can be converted into matter, matter can be converted into radiation, and it is correct also. Are you able to understand? So he said that electron, it is not just moving like a particle, it is moving like a wave. And what kind of wave? It is moving like a stationary wave. So in waves topic we study about stationary waves, no? Stationary waves means what? The waves which are produced in strings of a musical instrument. For example, if strings of musical instruments, if they are vibrated, so here stationary waves will be formed. Are you able to understand, ma? So this string, it starts oscillating like this. Are you able to understand? So perfect wavelengths are created here. Are you able to understand? And what is the importance of a stationary wave? The importance of a stationary wave is energy is trapped here. energy waves లో these points they are called nodes, no? So these points of zero displacement, they are called as what? They are called as nodes. And these points they are called as antinodes. Are you able to understand? So these node points, they are always in rest position. Only remaining part of the wire will be oscillating. So energy is trapped in this condition. But in the form of, in the case of general waves, traveling waves, energy travels from one place to another place. But here, in the case of stationary waves లో ఏమవుతుంది? ఎనర్జీ విల్ బి ట్రాప్డ్. Okay, so he said that these electron also, they are revolving around this nucleus as if they are present in a stationary wave. So energy is trapped here. Are you able to understand? And here perfect wavelengths are present, you know. 1.2 wavelength, 1.3 wavelength, it is not possible. Only one wavelength, 2 wavelengths, 3 wavelengths are possible. It means that wherever electron is starting, after completing its motion around this orbit, again it should reach the same point in the same phase and in the same position. Are you able to understand? ఎక్కడి నుంచి ఏ ఫేజ్లో స్టార్ట్ అయిందో రిటర్న్ అయ్యేటప్పుడు కూడా మళ్ళీ అదే ఫేజ్కి అది రిటర్న్ అవ్వాలి. In that condition, electron behaves like a stationary wave and its energy will be trapped. Are you able to understand? If a circumference of this orbit is 2 pi r, circumference of an orbit 2 pi r only, normal formula, then this total 2 pi r, it should be equal to n into lambda. What is lambda? Wavelength. How many wavelengths? Perfect wavelengths. N wavelengths. N is 1, 2, 3, 4 like this. 1.2 not possible. 1.3 not possible. Are you able to understand? So total length or total circumference. So how electron will rotate? It will make a perfect number of wavelengths. Then only it behaves like a stationary wave. అంటే ఎక్కడి నుంచి స్టార్ట్ అయిందో కరెక్ట్గా అదే ఫేజ్లో మళ్ళీ అది ఎండ్ అవ్వాలి. Are you able to understand? And according to de Broglie's hypothesis, we know that lambda is equals to h by mv. Okay, ma? Wavelength of particle or wavelength of radiation is equals to lambda divided by momentum of the particle. Momentum means mass into velocity. Or you can write h divided by p also. Okay, this we will study in dual nature of matter. Are you able to understand? So take this equation, substitute here, then I will get 2 pi r is equals to n into lambda value is h by mv. Okay, ma? So therefore if I take these values to this side, then I will get mvr is equals to nh divided by 2 pi. Okay, so this is the proof of Niels Bohr model given by de Broglie. So this was the statement which was given by Niels Bohr, and de Broglie has proved this one with the help of electron, wave nature of electron and electron moving in stationary orbits. Understood now? That's it. Okay, so here what is the node point I have to write? Node point is that after completing one rotation, okay, electron should end on itself in same phase. Okay, then it behaves as if it is in a stationary wave and energy is trapped. Energy is trapped, and so electron cannot lose energy. Electron cannot lose energy as far as it is in the same orbit. Okay, ma? So as long as it is present in the same orbit, it doesn't lose energy. Just like stationary waves also, there doesn't transport energy, no, energy will be present there only. In between two nodes only, energy will be trapped. So he gave that electron is also behaving like a stationary wave, and that was the perfect explanation. Okay, and partially this is correct also. Okay, ma? That's it. Means the amount of energy required to send the electron from one orbit to another orbit. That is called as excitation energy. Second orbit నుంచి ఫస్ట్ నుంచి సెకండ్కి వెళ్ళాలి, దానికి కొంచెం ఎనర్జీ అవసరం కదా, some energy is required. So if you supply that much difference of amount of energy, it can travel from first orbit to second orbit. That energy is nothing but excitation energy. Clear, nama? So therefore, what is excitation energy? Energy required to send electron to higher orbits. Are you able to understand? So therefore, for example, if it wants to travel from first orbit to second orbit, 1 to 2 it want to travel. So what is the energy of first orbit, ma? It is minus 13.6 electron volts. For example, if I discuss in hydrogen kinta energy untundi kada. Okay, ma? See, ma, for other atoms the equation is different. For other atoms it is minus 13.6 z square divided by n square. This is the equation, no? We are discussing only about hydrogen only. Okay. So for hydrogen, energy of first orbit is minus 13.6. Energy of second orbit is how much? Minus 3.4 electron volts. Okay. So how much energy difference I have to supply? That is called as excitation energy. That is equals to E2 minus E1. This is the amount of excitation energy. Clear now? So E2 value is minus 3.4 minus of E1 value is minus 13.6. Clear? So finally it is plus 10.2 electron volts of energy. Okay. So if you supply exactly this much amount of energy, then electron will take this energy and it will go to second orbit. Okay, ma? Now see here, we have supplied negative energy or positive energy? Positive energy we have supplied. So positive itself means we have supplied energy. Positive antune meaning emi మీరు ఎనర్జీని సప్లై చేసినారు అని అర్థం. నెగటివ్ అంటే అది రిలీజ్ చేసింది అని అర్థం. క్లియర్ నమ్మా? Positive, this much amount of energy I have supplied. Okay. Similarly, second one is excitation potential. This is excitation energy, ma, and this is excitation potential. Potential means what? Potential is nothing but work done per unit charge, no, ma? Potential is nothing but work done per unit charge. Clear? So therefore, how much amount of potential I have to supply? So instead of supplying energy, I will supply potential. Electric field lo electric potential untundi kada. Potential is what? Nothing but work done only. Are you able to understand now? So electron should be accelerated in how much potential, so that it has the ability to travel from one orbit to another orbit. That is called as excitation potential. Clear now? So therefore, how can I write the definition of this one? So the minimum potential in which electron should be accelerated so that it can move to higher orbits. That is called as excitation potential. And how can I calculate excitation potential? Okay, ma, very simple. Excitation energy divided by charge of electron. This is the method of calculating excitation potential. Understood, Nama? First of all, we studied excitation energy, no? That excitation energy you just divide by charge of electron. Then electron volts converts into volts. Are you able to understand? See, let us take this example. So in hydrogen atom, electron wants to travel from first orbit to second orbit. Same condition. It wants to travel from first orbit to second orbit. Okay, listen carefully. So excitation, okay, so excitation potential, how can I calculate? Excitation energy. What is the excitation energy I have calculated? 10 point. Okay, so 10.22 electron volts divided by what I have to divide? Charge of electron. What is the charge of electron? E is the charge of electron. So therefore E and E, if they get cancelled, then what is left? Only volts is left. So therefore 10.22 volts, that is my answer. Understood, no? So same energy, if I divide by E value, then it converts into volts, that's it. Okay, so this is about excitation potential. Okay, so then we study about the next one, which is called as ionization energy. Okay, third one is, so all these terms you should be careful now, because questions will be framed on these terms only. Ee terms meedane questions frame chestar. Okay, next is ionization energy. Ionization, SATION or ZATION, I forgot. SATION. Ionization energy. So what is meant by ionization energy, ma? In chemistry also you should have studied, no? Chappandi. Ionization. Yeah, outermost launch na? Outermost shell. Sima, you can remove electron from anywhere, not only from outermost shell. That we study. Are you able to understand, ma? Minimum amount of energy required is nothing but energy required to remove electron from outermost orbit. If you want to remove electrons from innermost orbit, it is very tough. But ionization energy means what? Energy required to remove electron from its orbit. That is called as ionization energy. From wherever maybe the orbit is, first orbit, second orbit, third orbit, whatever it may. So if you remove one electron, neutral atom will become positive atom. Ante kada? Ion avutundi. Neutral atom will become ion. Ion means it should have some charge. So if you remove electron, the number of positive charges are greater than number of negative charges. In a neutral atom, what happens? Protons and electrons are equal in number, no? For example, neon తీసుకున్నారు. 10 protons will be there, 10 electrons also will be there. But if you remove one electron, what will happen? 10 protons are there, only 9 electrons are there. Are you able to understand? So positive charge is greater than negative charge. Automatically the atom will become positively charged atom. Are you able to understand? So removing an electron from any orbit is called as ionization energy. Okay, so right. Okay, so energy required to remove an electron from outermost orbit, or we will write from any orbit. Okay, ma? Permanently. Or here you can write minimum energy is called ionization energy. Okay, ma? Now I will take one condition. For example, if I want to remove an electron from first orbit of hydrogen, okay, permanently I want to ionize, excitation energy is different. Excitation energy means what? Energy required to send the electron from first to second, first to third, first to fourth, or 2 to 4, that is called as excitation energy. But in the case of ionization, permanently I want to remove this one. It means that electron should be out of the attraction force of that particular nucleus. Nucleus to inga daniki sambandham undakodu. Okay. Now for example, if I take hydrogen, okay ma? So I want to remove electron from first orbit. Okay. Then can you say how much amount of energy I have to give? Huh? చాలా ఎక్కువ అంటే ఒక 10 kgs ఇద్దామా? చాలా ఎనర్జీ అంటే ఎంత? 10 kgs, 20 kgs, 30 kgs అంతా కావాలి. చాలా ఎనర్జీ. Sima. So what is the energy of electron in first orbit? Minus 13.6 electron volts. Clear number? So if energy of electron becomes 0, okay ma, then it is no longer under the attraction of nucleus. So we have to supply So already we discussed in the last class what is meant by negative energy. No, negative energy ante meaning emi, it is under the attraction of nucleus attraction lo undi ani artham. Okay ba? So nucleus attraction lo undakudante, if I want the electron not to be present in the attraction of nucleus, what I have to do? I have to make its energy 0 or either positive, but minimum energy is 0. No? So how can I make energy of electron to be 0? Energy of electron 0 ela cheyali? Supply same amount of positive energy. Minimum energy is that much amount of energy only. No? So what is the energy of electron in first orbit? Minus 13.6. So supply same amount of positive energy plus 13.6 electron volts of energy if you give, then its energy will become 0. 0 means it is no longer positive. No? Sorry, it is no longer negative. So it will move out of the orbit. That's all. That much amount of energy I have to supply. For example, electron is present in second orbit. What is the energy of electron in second orbit? Minus 3.4. So to remove electron from second orbit, how much energy I have to supply? Plus 3.4. Then its total energy will become 0. Then it permanently goes out of the atom. That's all. Are you able to understand? That's all. Energy entundo anta positive energy meer iste chalu, ekku energy em avasaram ledhu. Okay, that's it. Enduku తీయలేము? బ్రహ్మాండంగా తీయచ్చు. హీలియంలోనే తీసినప్పుడు హైడ్రోజన్లో ఎందుకు తీయలేము? ఆల్ఫా పార్టికల్స్ ఎలా తయారవుతాయి? ప్రోటాన్ యూ కెనాట్ రిమూవ్, ఎలక్ట్రాన్స్ వీ కెన్ రిమూవ్. Are you able to understand? Energy required may be greater, that's it, but it is not that we cannot remove the electron. We can remove the electrons. Clear ma? So in chemistry what should have studied? First ionization energy is less than second ionization energy is less than third ionization energy. It doesn't mean that you cannot remove. You can remove, you have to supply more energy, that's it. Okay ma? That's it. Understood? No? So our target is that energy of electron should become 0. So supply minimum that amount of energy. Okay? Sima, here it is minus 13.6. I have supplied plus 13.6. If you supplied more than 13, will anything happen? If you supply, for example, 20 electron volts of energy, ఏమవుతుంది? ఏం కాదా? No. Sima, for example, if I supply 20 electron volts of energy, but required energy is how much? Only plus 13.6 is required. So 20 minus 13.6 will be how much ma? 16.4, no? 6.4 electron volts of energy. So electron will take this energy and this extra energy will be converted into kinetic energy. The extra energy amount, it will be converted into kinetic energy. If you give only 13.6, exactly 13.6 if you give, electron will move out of atom. And after moving out of atom, it will be in rest position. Because it doesn't have any energy, no? బయటికి రావడానికి కావాల్సిన ఎనర్జీ ఉందంతే. It is in rest position. Are you able to understand? But if you give extra energy, with that extra energy, it attains kinetic energy. It starts traveling with a velocity. So that is what happens. Are you able to understand? No? So that amount of energy is called as ionization energy. Minimum amount of energy to remove electron from any orbit. Okay, ma? So now next we have to study about ionization potential. ionization potential, fourth one. So what is Indra? Time ekko ainatlundi. Okay. Ionization potential. Ionization potential means what? Again same concept only. So ionization energy divided by charge of electron. Electron volts should convert into volts. That minimum amount of potential is called as ionization potential. Okay ma? So write down. So minimum potential required. See ma, potential is nothing but work done per unit charge. Potential antene work. Okay? Don't think potential endo kotta padam anukunnaru. Potential is nothing but the amount of work which you are doing. Are you able to understand? So minimum potential required to remove an electron permanently out of atom. This is called as ionization potential. Okay ma? So how can I calculate ionization potential ma? Ionization energy divided by charge of electron. Okay, same concept. For example, if you take hydrogen, electron in first orbit, okay ma? So what is the ionization potential? It is 13.6 electron volts divided by E. So E and E get cancelled, so 13.6 volts. So if I give this much of potential to that electron in the first orbit of hydrogen, then it takes that energy and it moves out of the atom permanently. Okay? If you give more than this potential, no problem. Kani takku iste matram alladu. That's it. So this completes our theory part on what you call atoms, atomic structure. So we will do question. Beam of alpha particles of velocity 2.1 into 10 power 7 meter per second. It is scattered by gold foil. So find the distance of closest approach. E by m value is given. What is meant by E by m? This is called charge to mass ratio. Charge of electron we know 1.6 into 10 power minus 19 coulombs. And mass of electron is 9.1 into 10 power minus 31 kg. So that calculations will become simple. Directly he gave E by m ratio, charge by mass ratio of electron. Clear? So therefore what is meant by distance of closest approach? Already we have studied the equation or shall I calculate it one more time? For example, if this is the nucleus of gold, are you able to understand? So from here an alpha particle is being projected, okay, with a particular velocity of v naught. This is the velocity of the alpha particle. So when the separation is very large, then what is the initial kinetic energy of the total system? Initial kinetic energy of the total system is only because of kinetic energy of alpha particle only, no? Initially only alpha particle was having velocity. So only alpha particle will have kinetic energy. And what is the equation for kinetic energy? It is half m v naught square. This is the initial kinetic energy. That's all. Similarly, when alpha particle is present at a very large distance, then initial potential energy is how much ma? It is 0. That's all. Now what happens? This alpha particle, it starts coming closer to the nucleus, and somewhere at this point the final velocity of alpha particle will become 0. That's all. Why the distance? Why the velocity of alpha particle becomes 0? Because nucleus is positively charged. Alpha particle is also positively charged. So velocity continuously decreases, and at a distance of closest approach, at this distance which is called as R0, clear now, its velocity will become 0. And what is this R0 called? This is called as the distance of closest approach. Are you able to understand now? So therefore final kinetic energy final kinetic energy is 0. Nucleus cannot move because this is a heavy body. Only velocity of alpha particle will become 0. So final kinetic energy is also 0. Final potential energy. Now two charges, they are present at a separation of R naught. No? Two charges, they are present at a separation of R naught. Then what is the equation for potential energy between two charges? Do you remember? So it is K Q1 Q2 divided by R. Already we studied in derivation, no? So when two charges are separated by a distance of R, then this is the formula of potential energy between them, electric potential energy. Okay? Gravitational potential energy is mgh, but this is which potential energy? Electric potential energy, which we will study in electrostatics. Clear now? So K means what? K means 1 by 4 pi epsilon naught. Okay ma? Q1 Q2 means Q1. What is Q1? Q1 is the charge of alpha particle. What is the charge of alpha particle? Charge of alpha particle ma? 2e. It will be having 2 times the charge of electron. And which is the second charge? The second charge is the nucleus. Okay ma? That one I can call it as Z into E. Z is atomic number, no? E is the charge of single electron. Z into E. Divided by, what is the distance between them? Distance of closest approach is R naught. So this is the calculation which we have done in the last class. Are you able to understand? So therefore, what he is asking actually, he is asking R naught value. Okay. So distance of closest approach, R naught is equals to 2z E square divided by 4 pi epsilon naught into, we will write the law of conservation of mechanical energy ma. So which force is acting ma here? Only electrostatic forces are acting. So what are the forces present between two charges? Forces madhyalo unna charge ne emantam electrostatic force. And electrostatic forces are what kind of forces ma? They are conservative forces. Clear? So if only conservative forces are acting, then what I can do? Then I can use law of conservation of mechanical energy. This is what I can use. What is law of conservation of mechanical energy? K1 plus U1 is equals to K2 plus U2. Already we have done all this calculation. Just for your understanding, I am doing once again. So what is the initial kinetic energy? Half m v naught square. Initial potential energy 0. Final kinetic energy 0. Final potential energy 2z E square divided by 4 pi epsilon naught into R naught. That's all. So therefore, I want R naught. I want distance of closest approach now. So R naught. So R naught is equals to 2z E square divided by 4 pi epsilon naught into half m v naught square. Are you able to understand now? So therefore, E by M ratio is given already. Just substitute all the values. Then you will get R naught value. Are you able to understand now? So therefore, 1 by 4 pi epsilon naught value is how much? 1 by 4 pi epsilon naught value is 9 into 10 power 9. Clear ma? 1 by 4 pi epsilon total value is 9 into 10 power 9. Now remaining values you have no Z. What is Z? Atomic number of nucleus of gold. Atomic number of gold 79. So Z value is 79. So there is one more E here. E means charge of electron, 1.6 into 10 power minus 19. And 1 E by M value already given. Are you able to understand? My E square can be written as E into E, no? Alage rayachu kada. 1 E by M ratio already given, 4.8 into 10 power minus 10 power 7. Another E will be there, no? That E value 1.6 into 10 power minus 19 coulomb, charge of electron. Clear? Substitute all the values and whatever answer you will get, that will be the distance of closest approach. Clear? Okay ma? So these are the calculations which we have done ma. So 2 only, Z is 79. E square can be written as E into E, no ma? Because 1 E by M value is given and 1 by 4 pi epsilon naught value is 9 into 10 power 9. So just we are substituting all the values, that's all. Clear? And what is this one? Velocity. Velocity is already given, no? 2.1 into 10 power 7. And E by M ratio 4.8 into 10 power 7. Just if I do all this calculation, this is the distance of closest approach. It means the distance between center of the nucleus and alpha particle will be this much. Which distance? This distance. center of gold nucleus and the final position of alpha particle, this distance. That is called as distance of closest approach. Okay. Let's calculate the impact parameter of a 5.0 million electron volt alpha particle scattered by 10 degrees when it approaches a gold nucleus of Z value 79. So what is meant by impact parameter? Already we have studied now. What is meant by impact parameter? Sigma. So if this is the gold nucleus, are you able to understand? And this is the line which is connecting the gold nucleus, straight line, which is connecting the center of the gold nucleus. So if an alpha particle travels in the same path, if alpha particles travels in this straight line, then it collides with this alpha particle and returns back. It traces exactly 180 degrees of what you call deviation angle. Clear number? But when alpha particle is here and when it travels like this, then what will happen? Then it cannot return exactly in 180 degrees path. 180 degrees lo aithe raaledu. So what will happen? It will trace this type of path. Okay. So then this deviation angle, if it is theta or alpha anything, then this perpendicular distance is called as B, which is called as impact parameter. That's what we have studied. So if the alpha particle undergoes what you call head-on collision in one dimension, then it will retrace the path. It will exactly travel in 180 degrees of deviation. But when it is not present in this line, then it cannot return back by 180 degrees. No? So there will be some angle of deviation. And that perpendicular distance between the two paths is called as impact parameter. Okay. And already we have written an equation for this impact parameter. No? What is that one? ZE square cot theta divided by 2 divided by 4 pi epsilon naught into half mv square. This is the equation. And what is meant by half mv square? Half mv square is nothing but initial energy of alpha particle. Kinetic energy of alpha particle number. And kinetic energy of alpha particle is already given. How much? 5 million electron volts. Or you can call it as mega electron volts also. Just substitute all the values, that's it. Okay. Z value. Gold nucleus, no? So Z value will be how much? 79. Charge of an electron? 1.6 into 10 power minus 19 coulombs whole square. Cot theta by 2. What is the angle of deviation? 10 degrees. So 10 divided by 2 divided by 1 by 4 pi epsilon naught can be written as I can write it as 9 into 10 power 9. What is 9 into 10 power 9? 1 by 4 pi epsilon naught value. Clear? Divided by half mv square. Half mv square is nothing but energy of alpha particle. And what is the energy of alpha particle? 5. 5 into 10 power 6. Okay, multiplied by 1 electron volt can be written as 1.6 into 10 power minus 19 joules. So here all the calculations we are doing in SI system. No? So therefore electron volts is not the SI system of energy. Joules is the SI unit. Okay. 1 electron, see 5 mega electron volt or million electron volt, how I can write 5 into 10 power 6 electron volts. I can write like this. Mega means 10 power 6. So 5 into 10 power 6 electron volt. But 1 electron volt is how much? 1 electron volt is 1.6 into 10 power minus 19 joules. So electron volts again how I have to write? 5 into 10 power 6 into 1.6 into 10 power minus 19. So this is the total energy of this alpha particle. That's what I have written here. 5 into 10 power 6 into 1.6 into 10 power minus 19. So cot 10 by 2 we don't know. That should be given in the question. Are you able to understand? No? Cot 10 by 2 means cot 5 degrees. No? Cot 5 degrees value we don't know. That's what options lo istar. Okay. So if you do this total calculation, that is my required answer. And the answer for this one is 2.6 into 10 power minus 13 meters. So 2.6 into 10 power minus 13 meters. That is our answer. Understood now what is meant by impact parameter? Okay. So if it travels in this line, then it will retrace the path. If it is exactly at striking the middle of the nucleus. కానీ మధ్యలోంచి ఒక పర్పెండిక్యులర్ డిస్టెన్స్ పైనుంచి వెళ్తుంది అనుకోండి, అప్పుడు ఎగ్జాక్ట్లీ రిటర్న్ బ్యాక్ అవ్వలేదు కదా, ఒక పర్టికులర్ యాంగిల్లో డీవియేట్ అవుతుంది. దట్ యాంగిల్ ఈస్ theta, and that perpendicular distance from the center of the nucleus is called as impact parameter. So find the radius of first orbit of hydrogen atom, and similarly what is the velocity of electron in the first orbit. So hence find the size of hydrogen atom. Clear number? So therefore what he is saying, radius of first orbit. These are the equations for radius and this is the equation for velocity. Are you able to understand? And this equation I can write as 0.53 into 10 power minus 10 n square divided by z. I can write like this also. Already we have discussed this equation number. So n square by z, if you take outside, then E naught h square divided by pi m e square. Value will be how much? 0.53 into 10 power minus 10. Or just you can write 0.53 into n square by z angstrom, because 1 angstrom is equal to 10 power minus 10 meters. 10 power minus 10 can be written as angstrom. Clear? So radius of first orbit of hydrogen he is asking now. So it means we are doing calculation for hydrogen. Okay. So hydrogen z value is 1, atomic number 1. And for which orbit he is asking? First orbit. First orbit means n value 1. Clear number? So just substitute. So radius of first orbit is equals to 0.53 into 1 square divided by 1 is how much? 0.53 angstroms. That is my answer for the first question. Clear no? Then what is the velocity of electron in the first orbit? Velocity. So again for hydrogen only, no? Again for hydrogen. So for hydrogen again z value is 1 and first orbit only he is asking, so I will take n value to be 1. So substitute all the values. So therefore velocity of electron in first orbit of hydrogen is how much? Z value is 1, charge of electron is how much? 1.6 into 10 power minus 19 whole square divided by 2 epsilon naught. Epsilon naught value is how much? 8.854 into 10 power minus 12. Multiplied by which orbit he is asking? First orbit. And h value, h is Planck's constant, and what is Planck's constant? 6.624 into 10 power minus 34. Okay. So if you do this total calculation, then I will get the velocity of electron in the first orbit. Clear? So what is its value which he gave? (2.2) into 10 power 6. Okay, no? So 2.2 into 10 power 6 meters per second. Okay? It means 22 lakhs of meters per second. That is the speed of electron in the first orbit. Very large speed. Okay? This question, calculate the radii energy of 3 lowest energy allowed orbits for electron in lithium 2 plus ion. Okay, ma? What is the energy of photon that when observed causes an electron in lithium 2 plus to be excited from n is equal to 1 to n is equal to 3 state? Okay. So which is the atom which he gave ma here? Atom given is lithium 2 plus. Okay. Now this radius is, equation of radius is there, no? 0.53 into n square by z angstrom. We have equation for energy also, 13.6 z square by n square. So all these equations, are they applicable for this lithium 2 plus or not? They are applicable, because all these calculations they are satisfied for only single electron species. Hydrogen we have only one electron, and which is the second one, helium. So from helium on also, if you remove one electron, then we have only one electron, because total electrons will be 2. So therefore these equations are satisfied by helium plus also. And which is the next element? Lithium. Lithium atomic number 3. It means how many electrons are there? 3 electrons are there. 2 plus means what? 2 plus means that you are removing 2 electrons. Now only 1 electron is present. So this is also single electron species. Clear number? Similarly, next atomic number is beryllium. Beryllium atomic number 4. So from 4, if you remove 3 electrons, then again it will become a single electron species. So therefore for hydrogen, helium plus, lithium 2 plus, beryllium 3 plus, these equations of energy, radius you can use. Are you able to understand now? So write the main note point. Note point is that calculations of Niels Bohr are satisfied for single electron species. And all of them they are single electrons only. అంతే కదా, లిథియంలో 3 ఉంటాయి, 2 తీసేస్తే 1 ఉంటుంది, బెరీలియంలో 4 ఉంటాయి, 3 తీసేస్తే 1 ఉంటుంది, హైడ్రోజన్లో 1 ఉంటుంది, దాన్ని తీయాల్సిన అవసరం లేదు. అలా ఇస్ ఇట్ క్లియర్? Now what is the first one? He is asking radius and energy of 3 lowest most energy orbits. So first we will calculate radius. Okay, so what is the equation for radius of okay ma? So what is the equation to calculate radius ma? So radius of nth electron is equals to 0.53 n square by z angstrom. This is the equation, no? Clear now? 0.53 into n square by z angstrom. That is the equation for radius. Okay. Now he is asking for lithium, no ma? Lithium atomic number. He is asking for how many orbits? First 3 orbits. 3 lowest energy states means what? 3 lowest energy states means first orbit, second orbit, third orbit. That's all, no ma? So n value 1, n value 2, n value 3. And z means atomic number, no? Atomic number of lithium is 3. So substitute all the values. So radius of first orbit is how much? 0.53 into first orbit is 1 square divided by 3. So do the calculation. R2 is equals to 0.53 into second orbit, 2 square divided by 3. Do the calculation. R3 0.53 into 3 square divided by 3. So if you do these calculations, you will get the radius of first orbit, radius of second orbit, radius of third orbit. Clear, no? And similarly he is asking energy also, no? What is the equation of energy? Energy equation chepandi. Minus 13.6 z square divided by n square electron volts. That is the equation for energy, no? Okay, ma? So this is the equation for radius of orbits. This is the equation for energy of electron in a particular orbit. Okay. Now here also same, for lithium only we are calculating, no? Lithium. So therefore z value is equal to 3. So what is the energy of electron in first orbit? Minus 13.6 multiplied by 3 square divided by 1 square electron volts. Do the calculation. E2 is equals to minus 13.6 multiplied by 3 square divided by 2 square electron volts. E3 value is how much, ma? Minus 13.6 multiplied by z value. Z value is 3 square divided by 3 square electron volt. So that's it. Okay, ma? So do all these calculations first of all and see radius of first orbit, radius of second orbit, radius of third orbit. For which atom? For lithium. For other atoms it will change. For lithium these are the radius. And these are the energy. Energy of first orbit, energy of second orbit, energy of third orbit. Clear now? Now he gave one more question. Next question is, what is the energy of photon that when absorbed causes an electron in lithium 2 plus to be excited from n is equal to 1 to n is equal to 3. Okay, now I want to make this electron in lithium to travel from which orbit to which orbit. Clear, no? So this is the first orbit, this is the second orbit, and the third orbit may be somewhere here. Okay, so I want to make this electron to travel from first orbit to third orbit. Then what I have to do, can you say? Electron ni first orbit nunchi third orbit ki pampinchalante em cheyali? I have to supply energy. That's it, no? I have to supply energy, because energy of first orbit is less than energy of second orbit is less than energy of third orbit. So paiki velle koddi orbit energy perugutu veltundi. It means I have to move from lower energy state to higher energy state. It means I have to supply energy. How much energy I have to supply? Enta energy ni supply cheyali? Energy difference, that's it. Clear now? So therefore, here I am writing. Energy supplied is how much? Energy supplied is equal to, clear now? How much? E3 minus E1. That is how I have to write number. Energy of third orbit minus energy of first orbit. Rendit energy difference kavali. What is the energy of third orbit? Minus 13.6. Minus of energy of first orbit? Minus 124.4 electron volts. Okay, ma? So if you do this calculation, that much amount of energy if I supply, then electron will move from first orbit to third orbit. అదే కదా నీల్స్ బోర్ మోడల్లో మనం చదువుకున్నది. క్లియర్ నమ్మా? ఇఫ్ ఎనర్జీ షుడ్ రిటర్న్ ఫ్రమ్ హయ్యర్ ఆర్బిట్ టు లోయర్ ఆర్బిట్, అది ఎనర్జీని ఎమిట్ చేయాలి. ఇట్ షుడ్ రిలీజ్ ఎనర్జీ. బట్ ఇట్ ఈస్ మూవింగ్ ఫ్రమ్ లోయర్ టు హయ్యర్ నమ్మా, ఇట్ షుడ్ అబ్జార్బ్ ఎనర్జీ. ఓకే? సో దేర్ ఫోర్ ద ఆన్సర్ విచ్ యూ షుడ్ గెట్ ఈస్ 108.8 electron volts. 108.8 electron volts. This much amount of energy should be absorbed. And who will give this energy? ఆ ఎనర్జీ ఎవరిస్తారు? Light. If you incident light energy, light is made up of photons, no man? Light is made up of photons. So one photon should have this much amount of energy. ఆ లైట్ యొక్క ఫోటాన్కి ఎంత ఎనర్జీ ఉండాలి? ఇంత ఎనర్జీ. Then electron absorbs that energy and it moves from lower orbit to higher orbit. That's it. Okay. So what is this energy? This is the energy of required photon. Okay. Energy of photon. That's it. One question, ma. So calculate the wavelength of second line of Lyman series. So spectral series we have studied nama previously. Spectral series are L, BP, BP. This we have studied, no? What is L here? L is nothing but Lyman series. Okay, ma? So Lyman series means what? N1 value will be 1. N2 value will be 2, 3, 4, 5 and anything. This is called as Lyman series, no? So what is meant by N1 is equal to 1? N1 is equal to 1 means electron should finally come to first orbit. From which orbit? From any one of the higher orbits, second orbit, third orbit, fourth orbit. That is called as Lyman series. And the frequency of radiation or wavelength of radiation will lie in which spectrum? Wavelength ఏ స్పెక్ట్రంలో ఉంటుంది? Will it be infrared, will it be ultraviolet, or will it be in visible region? In which region? Lyman series, in ultraviolet region. Because electron is returning to first orbit, no? The energy gap between second orbit and first orbit is very large. Are you able to understand, Nama? So the energy released also will be very large. So therefore energy is more powerful. So that energy will be lying in ultraviolet region. We know that ultraviolet rays, they are powerful rays, no? When compared to visible light. Are you able to understand, no? Okay. Now the question is, what is meant by second line of Lyman? Second line means Sima. When N1 is equal to 1 and N2 is equal to 2, this is called as first line. Okay. This is called as first line. Or you can call it as H alpha line. Second line is called H beta line. Third one is called H gamma line. Like that also he will ask in the exam. Clear, no? So N1 is equals to 1, N2 is equal to 3. Then it is called as second line. So this language you should remember. So he may ask the same type of question in any one of the series. So when electron is returning from 1 to 2, it is called as first line. Clear? When electron returning from 3 to 1, then it is called as second line. When it is returning from 4 to 1, it is called as a third line. Like this you have to remember. Understood, Nama? So therefore, wavelength of radiation. What is the formula for calculating wavelength of an electromagnetic radiation? Chapandi. 1 by lambda is equals to RH into 1 by N1 square minus 1 by N2 square. Okay, ma? So instead of remembering this formula, you can also remember for R Z square also. So Z is the equation which you can apply for any one of the atom. But if I am calculating for hydrogen, Z value will become 1. Are you able to understand, ma? So therefore I can write for hydrogen. Okay. For hydrogen Z value is equals to 1, no? So therefore 1 by lambda is equals to RH into, clear ma, 1 by n1 square minus 1 by n2 square. So what is RH value? 1.07 into 10 power 7. Already we have explained you this one. No? So divided by 1 by, it is returning to first orbit, and it returns to first orbit from third orbit. So therefore if you do this calculation, that will be my required value of lambda. Okay, come on, make a note of this one. So the answer of this one is 1025 into 10 power minus 10 meters, or you can write 1025 into 1025 angstrom, because 1 angstrom is 10 power minus 10 meter. Okay ma, that's it. Okay ma, so the next question is, calculate the shortest wavelength of Bohr series. Now can you say what is meant by Bohr series ma? Bohr series means what? N1 value is 2, N2 value is 3, 4, 5, 6, like this. Are you able to understand? So this name, this mnemonic you should remember ma. L, B, P, B. L represents Lyman, B represents Bohr, P represents Paston, another B represents bracket, another B represents bracket, P represents Fund series. Are you able to understand? So therefore Bohr series means what? The order is 1, 2, 3, 4, 5 number. So what is this order? N1 value. N1 value 1, N2 value, N1 value 2 for Bohr series. Okay, so N1 value is 2, N2 value is 3, 4, 5 and anything. So here the question is that shortest wavelength. What is meant by shortest wavelength? Shortest wavelength means what? Anybody, can you say? See, my energy of electromagnetic radiation, energy of electromagnetic radiation, E is equals to h nu, or I can write hc by lambda, or you can call it as energy of photon also, because photons, light is made up of photons, no? Radiation is made up of photons. Okay, so therefore E is equals to h nu or hc by lambda. What is meant by h here? H is called Planck's constant. Clear? Planck's constant, and its value is 6.624 into 10 power minus 34 joule second. Clear, no? And C is called what? C is called as speed of light. Speed of light. And what is its value? 3 into 10 power 8 meter per second. Are you able to understand? And what is meant by lambda here? Lambda is called as wavelength. Okay? Are you able to understand? So therefore he is asking what is the shortest wavelength? If wavelength is present in denominator or numerator? Denominator. So if wavelength is small, shortest means very small, no? So if wavelength is small, what happens to energy? Energy should be largest. That is the meaning of this one, nama. Wavelength ekkadundi? Wavelength denominator lo undi kada. These are the two equations of energy. So lambda is present in the denominator. If denominator is small, total value will be very large. Because already previously I gave you one example number, 10 by 2, 10 by 5. Which one is bigger? 10 by 2 is bigger. Why 10 by 2 is bigger? Because 2 is smaller. The value in denominator, it should be smaller, then total value will be bigger. Okay. Therefore he is asking that wavelength, which is shortest, means what? Energy should be maximum. Okay. So therefore what I understand, therefore energy of radiation should be maximum. Okay. Now can you say electron should return from which orbit so that energy is maximum? Can you say energy ekkadi nunchi vaste, electron should return from which orbit so that energy is maximum? 3 to 2, 4 to 2, 5 to 2. It should return from infinity. Are you able to understand, Masima? Energy difference between 3 and 2 is smaller. Energy difference between 4 and 2 is bigger. Energy difference between 5 and 2 is still bigger. As number of orbit increases, energy increases or decreases? Orbit పెరిగే కొద్ది energy పెరుగుతుందా తగ్గుతుందా? Energy increases. So if energy electron returns from third orbit, less amount of energy is released. Electron returns from fourth orbit, some more energy is released. Fifth orbit, some more energy. Sixth orbit, some more energy. So if it returns from infinity, maximum energy will be released. That is the meaning of this one. No? Therefore, N2 value should be how much? N2 value should be infinite. Then the energy released will be maximum. Are you able to understand? So therefore substitute, what is the equation for wavelength? 1 by lambda is equal to RH into 1 by N1 square minus 1 by N2 square. Z value is 1. No? We are doing all these calculations for hydrogen only. RZ square is the general equation. I am just writing RH. 1 by N1 square minus 1 by N2 square. So 1 by lambda is equals to 1.07 into 10 power 7 multiplied by 1 by Bohr series, no? 2 square minus 1 by infinity. Are you able to understand? 1 by infinity value 0. 1 by infinity is 0. So therefore 1 by lambda is equals to 1.07 into 10 power 7 multiplied by 1 by 4 minus 0. So therefore calculate lambda value. That is our answer. Understood now? That's it. Okay. So therefore what we understand, 3646 angstrom. Okay, ma? 3646 angstrom. That is the answer. So therefore what we understand that if you ask shortest wavelength, then electron should return from infinity. Many times this question was asked previously. Clear? Longest wavelength means, can you say? 3 to 2. Longest wavelength means, Sima, wavelength is present in denominator, no? If this lambda should be maximum, energy will be minimum. అంతే కదా? ఈ వాల్యూ ఎక్కువగా ఉందంటే ఈ వాల్యూ తక్కువగా ఉంటుంది, బికాస్ లాంబ్డా ఈస్ ప్రెసెంట్ ఇన్ డినామినేటర్. అండ్ విచ్ ఈస్ ద మినిమం వాల్యూ? మినిమం వాల్యూ మీన్స్ దట్ మినిమం ఎనర్జీ మీన్స్ electron should return from 3 to 2, because this is the least energy difference, no? If it returns from 4 to 2, energy difference will be greater. ఎంత ఎనర్జీ రిలీజ్ అవుతుంది? హౌ మచ్ ఎనర్జీ విల్ బి రిలీజ్డ్? ఎనర్జీ ఈక్వల్ టు ఎనర్జీ డిఫరెన్స్ బిట్వీన్ 2 ఆర్బిట్స్. 2 ఆర్బిట్స్ మధ్యలో ఎనర్జీ డిఫరెన్స్ ఎంత ఉందో అంత ఎనర్జీనే కదా రిలీజ్ అయ్యేది. So when compared to third orbit, fourth orbit has higher energy. So electron should not return from fourth orbit, it should return from third orbit. Then the energy will be least and wavelength will be maximum. Understood nama? Difference between shortest wavelength and longest wavelength. Okay? So therefore you better make a note point. Note point is that if wavelength is shortest, energy will be maximum. Okay ma? Then electron should return from where? From infinity. Are you able to understand ma? First note point. Second note point, if wavelength is maximum, then energy should be minimum. Then energy, E means energy ma. Energy should be minimum. And from where electron should return ma? Electron should return from the next orbit itself. Okay? Therefore electron should return from where? From next orbit. That's it. Immediately whatever next orbit is present, from where if electron returns, then energy released will be minimum, wavelength will be maximum. That's it. Okay? So see this question now. Which state of triply ionized beryllium has the same orbital radius as that of ground state of hydrogen atom? Okay? And then you are supposed to compare their energies also. Are you able to understand? First of all, let us see what is meant by triply ionized beryllium. Beryllium 3 plus, no, what is the atomic number of beryllium? 4. So 4 electrons are present, out of them 3 electrons if they are removed. Are you able to understand? Then it will behave like a hydrogen-like species, no? Hydrogen has only 1 electron. Okay? So from beryllium also, if you remove 3 electrons, now here also there is only 1 electron. So here also we can apply the equations of Rutherford and Niels Bohr. Are you able to understand? Because this also behaves like a hydrogen-like species. Arthamavutundi kada? So therefore, which state? Which state means what? Which orbit? State means orbit. Which orbit of triply ionized beryllium has same orbital radius as that of ground state of hydrogen? What is meant by ground state of hydrogen? In normal state, hydrogen has how many electrons? One electron. That one electron, is it present in first orbit, second orbit, third orbit or fourth orbit? First orbit lone untundi kada. That is called as ground state. So the normal state of hydrogen is called as ground state. The question is that which orbit of beryllium will have same size as that of first orbit of hydrogen? Orbit sizes, they are not same in every atom. Because radius of orbit depends on what? Radius of orbit depends on 0.53 m square by z angstrom. Do you remember this one? Okay, ma? Radius of nth orbit. We have done this calculation in our Niels Bohr model. No? Radius of nth orbit formula is 0.53 n square by z. So n is number of orbit. If number of orbit changes, radius changes. Z is atomic number. If atomic number changes, then also radius will change. So it is dependent on definitely z value. So the radius of first orbit of beryllium, radius of first orbit of hydrogen, they are not same. They are different. Are you able to understand? So therefore what he is asking that radius of nth orbit of beryllium 3 plus should be equal to radius of first orbit of hydrogen. That's what he is asking now. I think the given question. Then you are supposed to find out what is that n value which has the same radius as that of first orbit of hydrogen. First orbit of hydrogen ki enta size untundo, beryllium lo oka orbit ki ante size untundi. Adi e orbit? Adi question. Let us, I don't know. Clear ma? So therefore do the calculation. 0.53 multiplied by what is n value? I don't know. N square divided by what is the atomic number of beryllium? 4. So this is also equal to 0.53 into 1 square divided by what is the atomic number of hydrogen? 1.53, 0.53 get cancelled. So n square is equal to 4. So the n value is equals to 2. That is my answer. Okay. So therefore second orbit of beryllium 3 plus will have the same radius as that of first orbit of hydrogen. Okay. It means the first orbit of beryllium is still smaller. Ante kada. Second orbit of beryllium is equals to the size of first orbit of hydrogen. First orbit of beryllium, it is still smaller. That is the meaning of it. Clear nama? Therefore what I write, therefore second orbit of beryllium 3 plus is having same size, as that of what? As that of what? No? First orbit of hydrogen. That is the question. Clear now? Therefore then he is asking, you have to compare their energies also. Radiuses we have compared. Energies also I have to compare. Okay. So what is the energy of beryllium of second orbit? Energy formula? Minus 13.6 z square divided by n square. Values anni batti pattesayali meeru. This is the equation of energy, no? Minus 13.6 z square by n square. See here, radius is measured in angstroms. Energy is measured in electron volts. Clear? If this is the equation. Electron volts you can write in calories also, you can write in joules also. Are you able to understand? Okay. So therefore minus 13.6 multiplied by z value 4. 4 square divided by which orbit? Second orbit, 2 square. So therefore minus 13.6 multiplied by 16 divided by 4. So therefore minus 13.6 multiplied by 4. Do this calculation. 6 4s are 24, 4 3s are 12, 14, 4 1s are 4, 4. So 44.4 electron volts. So that is the energy of second orbit of beryllium. Are you able to understand, ma? Similarly, what is the energy of first orbit of hydrogen? Energy of first orbit of hydrogen minus 13.6 z square divided by n square. So minus 13.6 multiplied by z value is 1 square. This is also 1 square. So minus 13.6 electron volts. So that is the energy difference. Are you able to understand? So therefore, what is the difference of energy? Difference of energy also you can calculate. Ratio of energies also you can calculate. Whatever you want, whatever is given in the data, in the options, according to that you can see. So energy difference is how much more? So minus 44.4 minus of minus 13.6. So do this calculation, you will get the energy difference between both of them. Okay. So he is asking to find out comparison number. Comparison means generally we have to take division, ratio of both of them. So therefore, energy of beryllium divided by energy of hydrogen. What is the energy of beryllium? Sima, this is 4104, this is 5, no? Sorry, 54.4. And here also 54.4. Okay. Energy of beryllium is how much? 54.4 divided by energy of hydrogen 13.6. How much it is? 4. So it means energy of second orbit of beryllium is having how much more energy? 4 times more energy when compared to first orbit of hydrogen. Clear? That's it. So there is a 10 kg satellite. It is rotating around Earth for every 2 hours in an orbit having a radius of 8,000 kilometers. So it means in every 2 hours it is making one rotation around Earth, and in which radius? In a radius of 8,000 kilometers. So assuming that Bohr's postulate of angular momentum is applicable for satellites. See, for Bohr's postulate is applicable only for first orbit of hydrogen. Clear, no? And also the theory, the concept of electrons rotating over a nucleus is, that is quantum mechanical model. But this planets rotating around the sun or satellites rotating around Earth, this is classical physics. Okay? Same laws are not applied in both of them. So if it is applied, if Bohr's postulate is applied for planets also and satellites also, then you have to find out this particular satellite is rotating in which orbit? Enno orbit lo idi rotate ayinatlu arthamu ani question. Are you able to understand ma? So therefore, what is meant by Bohr's postulate of angular momentum? It says that mvr is equals to nh by 2 pi. This is the equation, no ma? Angular momentum of an electron is an integral multiple of h by 2 pi. So in first orbit, it will have an angular momentum of h by 2 pi. Second orbit, 2h by 2 pi. Third orbit, 3h by 2 pi. So electron can be present in only that particular orbit only. That is called what you call Bohr's postulate of angular momentum. Clear now? So therefore, nth orbit, how can I calculate? Nth orbit is mvr multiplied by 2 pi divided by h. This is the nth value which I require. No? N is nothing but number of orbit. Which orbit? First orbit, second orbit, third orbit, fourth orbit. That is called nth orbit. No? Mass of satellite. So instead of electron, here I have to take satellite. Mass of satellite is how much? 10 kg. Clear number? Velocity. With what velocity it is rotating? Is it given? Velocity is not given. Radius 8,000 kilometers. This is given. 2 pi is a constant. H is also a constant. So only velocity I don't have. The tangential speed with which that satellite is rotating, that I don't have. So how can I calculate? Anybody can you say? Alpha. I don't know alpha. How can I calculate velocity in this condition? So for example, if this is Earth, this is the satellite. Okay, ma? Satellite will be rotating with a particular tangential speed. No? That tangential speed is nothing but v here. How can I calculate?
R into alpha.
There is no r, there is no alpha. Alpha is not there. A is also not there. How can I calculate? See, my time taken is given, no? Time taken is given. Omega value, or you can write just displacement is equals to velocity into time. So distance is equals to speed into time. Okay. Distance is nothing but 2 pi r, no ma? The circumference of this circle. Radius is given, no? Radius is capital R. So therefore, what is the length of this circle? 2 pi r. Okay. Distance is nothing but 2 pi r. Speed is tangential speed multiplied by velocity already given, no? 2 hours. Time is already given, no? 2 hours. So 2 into 3600 seconds. 1 hour is equal to 3600 seconds. No? 2 means you should not substitute only 2 here. Hours is not the SI unit of calculating time. No? Seconds is the SI unit of calculating time. Clear? So therefore, so 2 pi into what is the radius? 8000 kilometer. So 8000 into 1 kilometer, 10 power 3 meters. Clear now? So this is equal to tangential speed multiplied by 2 into 3600. From here you will get VT, no? Clear now? So take this VT and substitute here, then that is my required n value. Okay? Remaining calculations you have to do. So answer I will give you, n is 5.3 into 10 power 45. 5.3 into 10 power 45. So in this particular orbit, this satellite is rotating. Are you able to understand what? Not second orbit, third orbit, fourth orbit, 10th orbit, 10 power 45th orbit.